In this lesson, we are going to talk about sets. In Dart, sets and lists are collection types, but there is one fundamental difference between them, and that is that lists can contain the same item more than once and sets can't. In other words, sets are collections of unique values, whereas lists can contain duplicate values. So how do we declare a set in Dart? Well, here we can type var countries and then equals to open and close curly braces, and inside them we can type Italy, UK, and Russia, like this. So when we declare a set literal, we should use curly braces, and when we declare a list literal, we should use square brackets. Okay, so let's remove this list and focus on the countries set. And if you remember, when we talked about lists, we said that we can access items by index by using the subscript operator. However, the subscript operator does not exist when using sets. So if we try to type countries of 0, we are going to get an error that says the subscript operator isn't defined for the type set string. Instead, if we want to get an element at a certain position, we need to type countries.element at. And then we can pass the index like this. Okay, so what kind of things can we do with sets? Just like with lists, we can add a value and type add Iceland, like this. And if we print countries and run this program, we can see that we have a set with Iceland at the end. However, if we try to add Italy, which is an item that is already in the set, then we can see that Italy appears only once, and that's because sets only contain unique items. Also, we can remove an item by typing countries.remove Italy, like this. And if we try to remove an item that doesn't exist, the contents of the set remain unchanged. By the way, just like with lists, we can get the first and last item inside the set, as well as the length. And we can also check if a set contains a certain item, like this. Next, let's learn about some interesting operations that we can do with sets, but not with lists. And these operations are union, intersection, and difference. To show you how they work, let me rename this set to EU countries, as I want it to represent the countries in Europe, and here we can declare a var Asian countries equals, and then we can create a set that contains India, China, and Russia, like this. And then we can print EU countries.union with Asian countries. And if we run this program, we can see that the output is a set that contains the union of all these countries. And Russia is only included once, even though it belongs to both sets. Then we can print the intersection of these sets, and this is a set that contains only Russia. And we can also print the difference between these two sets, and this produces a set with the items that are on the first set but not on the second. In summary, sets are a type of collection that is similar to lists. Just like with lists, you can iterate on a set using a for-in loop, but the main difference is that sets only contain unique items, and as a result, they offer union, intersection, and difference methods, and these can be quite useful in many cases. Okay, so let's do an exercise. In this exercise, I'd like you to solve this problem about sets. Given two integer sets A and B, write a program to calculate the set of the elements that belong to either A or B, but not both. For example, given the following sets, the program should print 1 and 5. Then calculate and print the sum of all the items in the resulting set. So you can pause the video here and try to write this program. Okay, so let's see how to solve this. To get started, here we have our two sets, and we could calculate their union by typing final C equals A dot union with B. And this will give us a new set which contains all the items. But remember that we don't want the items that belong to both sets. In other words, we don't want the items that belong to the intersection of A and B. So to do this, here we can take the difference of A dot intersection with B, like this. And if we print C and we run this program, the console output shows 1 and 5. So this solves the first part of our problem. Next, we need to calculate the sum of all the values in the resulting set. To do that, we can use a for loop and type for var value in C. And then, like we did before, we could add a var sum equals 0 variable, and inside the loop we could type sum plus equals value, like this. And then we could print the sum at the end. And if we run the program now, we can see that it prints 6, which is the sum of these two values. Okay, so this completes our overview about sets. And when you work with collections, most of the time you'll be using lists. However, there are certain use cases where you may need to work with collections of unique values, and in these cases it's much easier to use sets. So keep in mind that sets are supported in Dart and use them if you need them. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about maps. Maps are an important type of collection that is often used in many programs, and maps are also called dictionaries in other programming languages. So what is a map? A map is a data type that we can use to store a collection of key value pairs. For example, here are some key value pairs that represent my name, age, and height. So let me show you how to define a map that contains these key value pairs. So over here we can type var person equals and then a pair of curly braces, and inside here we can add all our key value pairs. So we can type name within single quotes and then colon and then Andrea, like this, comma, and then on the next line, age, colon, 36, and then height, 1.84, like this. So what we have here is a map literal that holds these three key value pairs. And the important thing here is that these keys should be unique. And if we try to add another age key with a value of 40, then Dartpad tells us that two keys in a map literal shouldn't be equal. And while this is not an error in itself, it only makes sense to have unique keys. So this is how we can define a map. And notice how here I've defined all the keys as string literals, while the values are a mix of different types. And because we've declared this variable with var, we can use any types we want for the keys and values on this map, and Dart will infer the map type for us. However, if we want, we can explicitly tell Dart what types we want to use. To do this, we can replace this var with map with a capital M, and then within angular brackets, string, comma, dynamic, where string is the type of our keys and dynamic is the type of our values. And the reason this needs to be dynamic is that all these values have different types. So let's see what happens if we change this to string, like this. As we can see, we get two errors telling us that the element type int can't be assigned to the map value type string. And the same happens if we try to use double instead of string over here. So if we want to have values of different types, then we need to use dynamic. By the way, when we talked about lists, we have seen another way of defining type annotations on collection literals. And we can do the same here. So we can declare our map with var, just like we did before, and then before the curly braces, we can add some angular brackets and specify the types string and dynamic, like this. And this will tell Dart exactly what types we want to use. So the takeaway here is that whether we use lists, sets, or maps, type annotations work exactly in the same way. Strictly speaking, you don't have to add type annotations to your programs, but they help make your code safer by adding some constraints on the types that you use. And throughout this course, I'll always point out when it's a good idea to add type annotations and when it's okay to leave them out. Okay, so let's get back on track and see how to use maps. To access the values inside this map, we can use square brackets. So here we can type var name equals person, and then within square brackets, we can use the name key, like this, and then we can print name. And if we run this program, we can see that it prints Andrea. So what we have done here is to use the subscript operator to get the value that corresponds to the name key. And we have assigned this value to a new variable called name. Okay, so we have seen how to read values from the map. But what about setting new values? To set a value for a specific key, we can type person with age equals 37. And if we print person after this and we run the program, we can see that the age is now 37 inside the map. And if we want, we can also set new keys. For example, here I could type person and then within square brackets likes pizza equals true. And if we run this program now, we can see this new key value pair on the console. Okay, so before we continue, I want to focus on this line. So let me delete some old code from here and here. And if you look at this line, can you guess what is the type of this name variable? Is it a string because this value is a string? Or is it dynamic because dynamic is the type annotation of the values in this map? I'll let you think about this for a second and we can continue on the next lesson. In the last lesson, we ended with a question, and that is, what is the type of the name variable that we declared here? Well, one way to find out is to see what methods are available for use with this variable. So here we can type name dot, and we can see that we get a list of only 4 methods, and this doesn't include all the methods that are available when we work with strings. And that's because at compile time, Dart can't work out that this variable really is a string. So in this kind of situation, we need to give Dart a little help so that it can infer the type that we want. And the best way to do that is to use a special operator called as. So here we can type as string like this. And now if we type name dot, we have access to all the methods of the string type. And just to be clear, there are other ways of telling Dart that this is a string. For example, by declaring the type explicitly, like this, so that you don't need the as operator. But I do recommend that you use this syntax instead. And I can't explain this in enough detail right now, but we'll get back to this later on when we talk about classes. So the takeaway of this lesson is that if you declare a map that has dynamic values and you need to assign values to variables that are not dynamic so that you can access their methods, then you should use the as operator followed by the type that you want. Okay, so let's get back on track and continue on the next lesson. In the previous lessons, we have seen how to access values by key inside a map. So what happens if we try to access a key that doesn't exist? For example, here we could type var weight equals person and then within square brackets weight. And then we can print weight like this. And if we run this program, we get null on the console. So what is null? Null is a very special keyword in Dart and it means that there is no value. So in this case, the program prints null because there is no weight key on this map. So we will talk more in detail about null later on because it is an important concept. But for now, the important thing to remember is that whenever you try to get a value for a key that doesn't exist, you will get null. And if you want, you can write a condition to check if a value is null. For example, here you could type if weight equals null, then print no value, else print weight, like this. And if you run this program, you can see that it prints no value. So keep in mind that variables and expressions can be null and that you can check if something is null like this. Okay, so let me clean up some of this code and we can continue on the next lesson. Now that we know how to define a map, let's see how we can iterate through its key value pairs. And as we have learned, we can use a for in loop to iterate through a collection. So here we could try to type for var item in person like this, but as we can see here we get an error telling us that the type map string dynamic used in the for loop must implement iterable. So this message is not entirely clear at this stage because we don't know what an iterable is. So let's clarify this. An iterable is a collection of items that can be accessed sequentially. According to this definition, both lists and sets are iterables, and so we can iterate through a list or a set with a for in loop. However, a map is a collection of key value pairs, and that in itself is not an iterable. To get around this, here we can type person.keys, like this. And this will give us an iterable or a collection of all the keys in this map. So if we want to iterate through the keys, we can type for var key in person.keys and then print key like this. And if we run this program, it will print all the keys like this. But what if we want to print all the values? Well, one way of doing this is to print person, and then we can use key as a subscript. And we already know that this key exists because we are iterating through the keys themselves. So if we run this, we get all the values line by line. But if we only want to print the values and we don't care about the keys, there is a simpler way. And that is to type for var value in person.values and then print value like this. So depending on whether you need to iterate through the keys or the values, you can use a for in loop like this. Not only that, but there is also a third way to iterate through a map. So let me show you how. Here we can type for var entry in person.entries like this. And if we type entry dot, then here we can get access to both the key and the value. And we can use this to print the entry dot key and the entry dot value like this. And if we run this program now, we can see the first three values which are printed by the first loop. Then we can see these other values which are printed by the second loop. And at the end, we get both the keys and the values which are printed by the last loop. And the takeaway from this lesson is that there are different ways of iterating through a map. Okay, so let's continue with an exercise. Here is a new exercise for you. Given the following map of pizza prices, write a program to calculate the total for a given order. For example, given the following order, the program should print total $13. Note that if a pizza is not on the menu, the program should print something like this. Pineapple pizza is not on the menu. So take some time to solve this program and then I'll show you the solution. Okay, so let's do this together. And what we have here is a map of pizza prices and a list containing our order. So in order to calculate the total, we should iterate through all the items in the order and use them as keys in order to get the corresponding price from this map. And we will also need a variable that we can use to calculate the total order price. So let's write this. And over here we can type var total equals 0.0 and then for var item in order. And then we can type final price equals pizza prices with item like this. And then we need to check if the price is not null, because it's possible that we are trying to order a pizza that is not on the menu. So here we can type if price is not null, like this. And if it's not null, we can update total and say plus equals price, like this, else print, and then within single quotes, $item pizza is not on the menu. Like this. And at the end, after the for loop, we can print total. And here we need to escape the dollar symbol and then use it again to interpolate the total variable. And now we can run this program and we can see that the console prints a total of $30 for this order. And now we could try to add a pineapple pizza like this. And if we run this again, then the program tells us that the pineapple pizza is not on the menu. So this was a good example of how we can use maps, lists, and for loops to calculate the total for a pizza order. And as you can see, our programs are becoming more and more interesting as we make progress. So let's continue on the next lesson. Now that we know how to work with maps, lists, and sets, we can see how to nest them together to create more complex data structures. For example, suppose that we have a list of restaurants where each restaurant has a name, cuisine, and a list of ratings. So how can we represent data like this using collections in Dart? Well, in this case, we could use a list of maps. So let's see how to declare this in Dart. Over here, we can type var restaurants equals and then square brackets because the top level collection is a list. And then inside the brackets, we can add one map for each restaurant. So here we can type some curly braces like this. And to speed things up, I'm going to paste the key value pairs that correspond to this data. And since the ratings are a collection of values, here I've added them as a list literal. And then we need to add the 2 remaining restaurants. So here we can add a comma, and again, to speed things up, I'm just going to paste them in here. And now that we have this, we could iterate through this list with a for in loop. So here we can type for var restaurant in restaurants. And on each iteration of the loop, we can print restaurant like this. And then we can run this program. And as we can see, all the restaurants are printed on the console. So this is an example of how we can nest multiple collections to represent complex data structures. And as you can see, here we have a list inside a map, inside a list. And we can use the usual control flow statements to work with these collections. Okay, so let's do an exercise using this data. In this exercise, I'd like you to write a program that works with nested collections. So given the following list of restaurants, write a program that calculates the average rating score for each restaurant and adds it as an average rating key value pair for that restaurant. You can use the following code as a starting point. And just as a reminder, here we are using the as operator to make sure that the type of this ratings variable will be a list of double. So you can pause the video here and try to solve this program. Okay, so let's solve this together. First of all, we need to work out how to calculate the average rating for a restaurant. And the average rating is equal to the sum of all the ratings and divided by the number of ratings. So let's write the code for this. And here we can type var total equals 0.0 and then for var rating in ratings. And then inside the loop, total plus equal rating, like this. And then outside the loop, we can type final average rating equals total divided by ratings dot length, like this. And here we can uncomment this line and write restaurant with key average rating equals average rating, like this. And just to make sure that our program works, here we can print the restaurant and then we can run this code. And on the console, we can see that each restaurant now has an average rating key value pair. So this is how we can update a map that is nested inside the list. So let's continue on the next lesson. It's now time to introduce some new statements and operators that make it easier to work with collections. These statements are known as collection if, collection for, and spreads. So let's see how they work by starting with an example. Here we can type final colors equals, and then within single quotes, gray and brown. So this is a list of strings representing some colors, and then we can add 2 Boolean variables. The first one is const add blue equals false, and the second one is const add red equals true. So what we want to do is to add some more items to this list if these variables are true. To do that, we can type if add blue, then colors dot add blue, and we can also copy paste these 3 lines, and here we can say if add red, then colors dot add red. And then at the end of the program, we can print colors like this. And if we run the program, we can see that the console shows gray, brown, and red. So this list contains red because add red is true, but not blue because add blue is false. So if we want, we can write code like this to add some values to a collection only if certain conditions are true. However, Dart has a special feature called collection if that makes this task a lot simpler. To see how this works, we can declare a new variable called colors2, and we can initialize it with square brackets. And then inside here we can type gray and brown like this. And inside the collection we can also type if add blue, and then on the next line blue, comma, and then if add red, red. And at the end of the program we can print colors2. And if we run the program now, we can see that we get the same output for both print statements. but I think we can agree that this code is more readable than this one. And as we read code from top to bottom, it is easier to see which colors are added to the list. And just to be clear, this is not a regular if statement. In fact, regular if statements cannot be evaluated or used inside a list of elements like this. Instead, this is called collection if, and you can use it to add a value to a collection only when a condition is true. Okay, so let me clear the old code. And I'm also going to rename this variable to colors, so that we can continue using this code on the next lesson. Now that we have talked about collection if, I'd like to show you a new feature called collection for. To do that, suppose that we have a new variable called extra colors equals, and then yellow and green. So how can we add these colors to this list? Well, if we wanted, we could add one more line before the print statement that says colors.add all with extra colors. So add all is a method that we can use to add the values inside the list to another list. And if we run this program, we get gray, brown, red, yellow, and green. So this code works, but if we want, we can accomplish the same thing using the collection for feature. So this is how it works. Over here, we can type for var color in extra colors. And on a new line, we can type color. And remember to add a comma, like this. And what this does is to iterate through all the values in this list and adds them to this collection on the fly. And this may not seem like a big improvement, since it was easy enough to add all the extra colors with just one line. But the advantage of doing things this way is that we can initialize the colors variable with this list literal in one go. And we don't need to add extra values after it has been declared. In any case, I'm about to show you one more Dart feature that makes writing this code even easier. So let's continue on the next lesson. In the last lesson, we have seen how we can add multiple values to a list with collection for. However, it would be nice if we could remove this loop and just type extra colors like this. Now, this code is valid, but look at what happens if we run the program. So something is wrong here, because the yellow and green colors have been added as a list object. But this is not right, and what we actually want is to take these items out of this list and insert them as separate items inside the parent list. To do that, we can use a special operator called a spread. And to use the spread, we need to type 3 dots like this before our list variable. And if we run the program now, we can see that all the colors are now listed correctly. So whenever you have a list variable or literal and you want to add its contents inside another list, you can use the spread operator. By the way, I should mention that collection if, collection for, and spreads are composable. So what do I mean by this? Well, over here I could add a new const add extra colors equals true. And then inside the list we can type if add extra colors. And this will only apply the spread operator and add the extra colors if this condition is true. By the way, the spread operator works not just with list variables, but with literals too. This means that we can copy this list literal from here and paste it here. And we don't need this variable. So as long as the expression to the right of the spread operator is a list, we can use it to add values to the parent list. In summary, we can use collection if, collection for, and spreads to more easily declare collections of values. And while this example program is very simple and doesn't do much, these features are very useful when we write Flutter apps. Because in Flutter we use a declarative syntax to specify how our UI looks like. So using these language features can really improve the style and readability of your code. Before we move on, I also want to mention that these features don't work only with lists, but with sets and maps as well. For example, here I can define this map that represents a restaurant with name and cuisine key value pairs, and I can also define a list of ratings like this, and I can include them in the map as a key value pair like this. And if I want, here I can use a collection if and type if ratings.len greater than 3. And as a result, this map will only have a ratings key value pair if there are more than 3 ratings. And if we want to add more than one key value pair if this condition is true, Then here we can add the spread operator followed by curly braces like this. And here we could type, for example, is popular and then give it a value of true, like this. Okay, so let's continue on the next lesson. In this exercise, we have a simple program that prepares a shopping list from a set of variables. So what I'd like you to do is to rewrite this program so that the shopping list variable is initialized using collection if, collection for, or spreads, and the program output is the same. As a reminder, you can find the source code for this program on the course GitHub repo at this location so that you don't need to copy everything by hand. Okay, so you can pause the video here and try to solve this. Okay, so let's do this together. As we said, we want to declare this variable only using collection if and collection for or the spread operator. To do this, we can add a new line inside these curly braces, and then we can move all these if statements and put them in here. And now we have some errors that we need to fix. As a first step, we can remove these curly braces because they are not needed with collection if. And then we don't want to use the subscript operator like this, but instead we just want to add a bananas key and use the bananas variable as the value. Then we can do the same thing with the next if statement. So again, we can remove the curly braces and change this line to become a key value pair, like this. Finally, we can update the last if statement and remove the curly braces. And because this grains variable is already a map, we can add it directly with the spread operator and type ... grains, like this. And as we can see, all the errors are now gone, so we can format this code. And as we can see, Dartpad has included each key value pair alongside the corresponding collection if statement in a single line. So it is perfectly fine to format the code like this, and in fact this is a lot more readable than what we had before. And now we can run the program, and as we can see the output is the same as before. And I think that this example really shows how using collection if and the spread operator results in much more readable code. Okay, so let's continue on the next lesson. Now that we know how to use collections in Dart, I want to talk about a topic that sometimes can be a little bit confusing. And that is what happens when we copy a collection in Dart. To explain this, let me show you a simple example. Over here we have an empty program, and here we can type final list equals 1, 2, 3. So there's nothing special here, and all we are doing is to create a list literal that contains these values. Then we can type final copy 1 equals list. And then we can try to modify one of the items inside this list by typing copy 1 of index 0 equals 0. And then we can print the contents of these two variables. So here we can type print list is list and print copy 1 is copy 1 with string interpolation. And if we run this code now, we can see that list contains the values 0 to 3, and copy 1 also contains the values 0 to 3. Now, this may seem a little bit strange because we have set the element at index 0 for the copy 1 variable. So we would expect this variable to contain these values. But what's unexpected is that this variable also contains 0 as the first item. So what's going on here? To explain this behavior, let me show you a diagram. So what we have here is a grid that represents the memory in our system. And what happens when we create a new list literal is that some memory will be allocated and reserved to contain these values. And when we assign this to a variable, Dart will associate that variable with a reference to the location in memory that contains these values. And if we want, we can create more than one variable pointing to the same memory. For example, if we create a copy 1 variable and we assign it with the list variable, then both variables will point to the same location. As a result, if we modify an item using this syntax, then this will affect both variables because they point to the same location. And this explains the behavior that we see when we run this program. So the bottom line is that when we assign a collection like this, then we are not really making a copy of the values, but we are just creating a new reference to the same collection. So how do we make an actual copy? Well, one way of doing this would be to create a final copy to variable and assign it with an empty list. And then we can copy all the items one by one. To do this, we could use a regular for loop or even a collection for, so that we can add items like this. So this would work, but there is an even simpler way, because we can use the spread operator. So all we have to do is to type ... list, like this. By using this syntax, Dart will create a new list and will add all the values of this list inside it. As a result, here we can type copy to of index 2 equals 4, for example. And then we can print copy to, like this. And if we run this program now, we can see that the first two lists are the same values, but the new list has 4 as the last value, which is different from this. And the reason this works is that here we are creating a new collection. As a result, Dart will allocate a new portion of memory and use it to make a real copy of whatever was inside this list. And because this list contains the values 0 to 3, then this list will also have the values 0 to 3. And if we modify the last item and give it a value of 4, then only this list will change, but not this one. In summary, we have just learned that in order to copy a list or collection, we can't just assign it to a new variable like this. But instead, we should use the spread operator, and this will guarantee that the original values are copied to a new location in memory. So I recommend that you experiment with this code and make some changes and see how they affect the console output. By the way, I should mention that there are also other ways of copying collections in Dart, but we are not ready to explore them just yet. And we will get back to this topic later on in the course, when we will talk about classes and learn about the difference between shallow and deep copy. Also, there are some common operators such as filter, map, and reduce, which are often used to transform collections, but we can't talk about them just yet, because we first need to introduce some more concepts. So for now, we have reached the end of this section about collections, and we can continue on the next section, where we will see how to use them in practice with a practical project. In this section, we are going to work on a cool new project and learn how to process spreadsheets in Dart. This is very valuable when you have spreadsheets with hundreds or thousands of rows and you need to run some business logic and generate a report. So by completing this project, we are going to learn about data processing in Dart and implement a real-world application. So let me tell you a bit more about this project. You see, since I started making tutorials and courses for the Flutter community, I have been using a time tracker app to log all my activities. For example, if I'm writing a new article, I will log a time entry with a tag of blogging. Or if I'm making some YouTube videos, I'll log my time as YouTube production. And over the years, I've accumulated thousands of time entries about all these different activities. And at the end of each year, I want to generate a report that tells me exactly how much time I've spent on each activity type. Now, this is something that to some extent I can do using formulas and filters in the spreadsheet themselves. However, I found that Dart is a great language to do data processing, and because Dart is a general purpose programming language, it is a lot more powerful than conventional spreadsheet software. So if you have a spreadsheet, you have an option to export this as a CSV file, which looks like this. And then you can use Dart to read this file and do some data processing. So in this section, we will build a command line app that can process CSV files, and our command line app will take this file as an input argument. Then it will do some number crunching and it will generate a report that looks like this. And what I like about this is that I can see where I'm spending most of my time, and I can use this to make decisions about how I grow my business. So this command line tool is very useful to me, and by showing you how to build it, you will learn how to do data processing in Dart. And while this project will be a command line app, once you learn about Flutter, you could take the same logic and use it to generate a cool data visualization app, for example by showing a pie chart of the time spent on each activity type. In summary, in this project we will learn how to read command line arguments, read a local CSV file from our system, process it line by line and extract all the information we need, and use collections to calculate and group the totals by activity type. And as we will see, this is quite easy to do, and we'll create a program that does all of this in just 30 lines of code. So let's get started in the next lesson. We are now ready to start creating our command lineup to process CSV data. As a first step, we can start from our terminal, and here we can type mkdir data underscore processing, and then we can cd to that folder, and then we can type code dot, and this will start a new VS Code instance using the folder that we have just created. And as a first step, we can create a new file and call this totals.dart. And then we can add the main method. So here we can type void main, and this will create an empty program. Now, the command lineup that we are about to build will take an input argument, which will be a path to a CSV file that we want to process. But how can we read this inside our program? Well, we can get all the command line arguments by adding an argument to the main method itself. So here we can type list of type string, and then arguments like this. And to show you how this works, I can print the arguments like this. And here I can save and open the terminal, and then I can type dart totals.dart. And as I can see, this prints an empty list. And if I run this with dart totals ABC, then we can see that the program prints ABC inside the list. So this is how we can read command line arguments. And since this program needs to process an input file, it is invalid to run the program without any arguments. So if we call this program without arguments, we would like it to fail gracefully by showing us the correct way of using it. To do this, here we can type if arguments.isEmpty, and then inside it we can print usage, and then dart totals.dart, and then input file.csv. And now that we added this, we can save the file and test things out. So here I can run dart totals.dart, and as we can see, we get this usage description. So this is fine, but we also want our program to terminate immediately when it is called without arguments. To do that, we can use a special method called exit. Now, exit is a special method that is defined inside the Dart.io library. And we can see that VS Code gives us the option to automatically import this. So if we press enter, then we can see that Dart.io is already imported for us. Now, this method takes an error code that we can use to tell the system that the program has failed. So, the convention with command lineups is that they should return an error code of 0 if everything went well, or return a non-zero error code if there was an error. So, in this case, we can call exit1, like this. Finally, we can declare a final input file equals arguments.first, and then we can print the input file, and then we can save our file and run the program. So if we call this without arguments, we get the usage description and exit immediately. But if we call this with an argument, then this is printed back to the console. And now that we know how to read this, we can continue on the next lesson. Now that we know how to read the file name inside our command lineup, it's time to grab a CSV file that we can use for testing. To do that, you can head over to the course GitHub repo, and if you navigate to projects and then data processing, here you can find this file called CSV export code with Andrea 2019. And if you open it, you can see all the contents as a preview. So this is the file that you want to download. And to do that, you can press this button over here that says raw, and this will show the file in raw format. And now you can right click and you can save this page to your local machine. So you can put this file anywhere you want, but I recommend saving it in the project folder for your command line app so that it is more easily accessible. So you can go ahead and save the file. And once you have done this, you should be able to open it in VS Code like this. Okay, so our next step is to go back to the source code, and here we want to find a way to read the file contents. To do that, we can remove the print statement, and here we can type final lines equals, and then file with a capital F, and then input file as an argument, and then dot read as lines sync. So what this command does is to create a handle or a reference to the file using the value that was passed as an argument, and then it reads all the contents in one go and returns them as a list of strings. As a proof of this, here we can add a for loop that says for var line in lines, and then we can print each line like this. And now we can save our file, and in the terminal we can type dart totals.dart, and we can press tab to select the file that we want. So let's choose our CSV file, and if we run this, we can see that all the lines are printed. So this is all we needed to do to read a file line by line. Before we continue, I want to point out a couple of things. The first one is that if we pass an argument name for a file that doesn't exist, then here we get a file system exception telling us that there is no such file or directory. And what follows is a so-called stack trace, which gives us more information about where this exception occurred in the source code. This includes some references to source code inside the Dart.io library, but also we have this line which points to our code, and if we command click on it, it takes us exactly to the place where the error occurred. So as you continue in your coding journey, keep in mind that errors like this may seem a bit obscure, but they are there to help you. So if you read them carefully, you can more easily diagnose them and find a fix. In this case, it would be best if we could check if a file exists before trying to read all the contents, and maybe show a more user-friendly message if our input argument is not a valid file path. This is easy to do in Dart, but it requires a bit of knowledge about asynchronous programming and working with futures, which is a topic that we will cover later on in the course. So for now, we will leave this code like this, but the main takeaway is that it's important to try to code defensively, so that our programs can fail gracefully when something goes wrong. Just like we have done here by showing the usage description when the user forgets to pass the input argument. Okay, so let's continue on the next lesson. In this lesson, we'll add all the data processing logic that we need to generate a report from our CSV file. Now, CSV stands for comma separated values, and as we can see, all the data values in this file are separated by commas. And this means that if we process this file line by line, we can split each line into a list of strings using comma as the separator. So before we continue, let's try to figure out what data we need from this file. The first line is a header, and it tells us the names of each column. For example, the first column is the job name. The second and third columns are the start and end time for a given task. Then we have a duration, which is the difference between the end and the start time. And then we have a comment followed by some tags and a few extra columns that we don't need. So if we wanted to calculate the total time spent, we would have to extract the duration from each line and then add all the durations together. However, the purpose of this tool is to give us a breakdown of all time spent on each activity type. So let's try to come up with some pseudocode that we can use to accomplish this. Okay, so given a list of lines that represent the contents of our CSV file, we can declare a variable called duration by tag, and this would be an empty map. Then we can remove the first line, as this only contains the header for the entire file. Then we can iterate through all the lines with a for loop, and for each line we can get all the values by splitting the line using a comma as the separator. And then we can read out the duration and tag values, which can be found at index 3 and 5. In fact, if we open the CSV file and count from the left, we can see that the job has index 0, clocked in and clocked out have index 1 and 2, duration has index 3, and so on. And we can read each column value by index. After this, we can update the duration by tag by adding the duration value. And once the loop is complete, we can print the duration for each tag. So once again, having some pseudocode is quite useful because we can sketch out a general outline for our algorithm. So let's continue on the next lesson where we will write the actual code to generate our report. We are now ready to write the code to generate our report. So first of all, we need to create our map. So here I can type final duration by tag equals to an empty map. And here I'm using a type annotation to specify that the keys will be strings and the values will be doubles. Then we want to remove the header from our list of lines. Because this is in the first line, here we can type lines.removeAt with position 0. And then inside the loop, we can remove this print line. And here we can get all the values by typing final values equals line.split using comma as the separator. And then we need to get the duration. Now, the duration itself should be a number. However, when we read the values from the CSV file, we get a list of strings. Not only that, but each value in this file is contained inside a pair of double quotes, so we need to be able to remove them. So to do this, here we can type final duration string equals values at index 3 and then replace all, and here we can replace all instances of double quotes with an empty string. So this will remove the double quotes and give us a string representation of the duration. Once we have this, we can type final duration equals double dot parse duration string, and this gives us the duration as a number. Next, we want to read the tag value. This is a string and we can obtain it by typing final tag equals values at index 5 dot replace all, and once again we replace double quotes with an empty string. And now that we have both the duration and the tag, we need to update our map. And since this map will represent the total duration for each tag, I think it would be better to rename this to total duration by tag, just so that it's clear what we are talking about. And in general, it's always a good idea to choose descriptive names for our variables, as they carry more meaning and they help others read our code. Okay, so let's carry on, and to update our map, here we can type final previous total equals total duration by tag with tag. So this previous total variable will contain the total duration for a given tag up to this point in the loop. But if it's the first time we encounter a given tag, then this value will be null. So here we need an if statement that checks if previous total is null. And if it is, we can type total duration by tag with tag equals duration. Otherwise, we already have a previous total, so we can add an else branch and type total duration by tag with tag equals previous total plus duration. So this completes our processing stage. And the next thing that we want to do is to show the results. To do that, we can add a for loop that iterates through all the entries in the map. And here we can declare a duration formatted variable and initialize it with entry.value.toString as fixed 1, so that it has only one decimal place. And then we can type final tag equals entry.key, and then we can print the name of the tag followed by the formatted duration, and we can add an h at the end so that we know that this represents the number of hours. So what we have now is a first working implementation of this program. So let's test this by saving our file, and if we open the terminal, we can run dart totals.dart and then our CSV export file. And if we run this, we can see that the report is printed to console. So this seems to work, however, it appears that one of the values has an empty key. And the reason for this is that some of the lines in this dataset don't have a tag. So it would be nice if the report could handle this by using some kind of placeholder tag. So what I suggest we do is that we modify this expression using the ternary operator. So here we can type entry.key equals to empty string question mark unallocated colon entry.key. So what this code does is to check if a tag is missing by comparing it with an empty string, and if that's the case, then we treat this as an unallocated task. And if we save and run the program again, then we can see that this works correctly. So this looks good, but in addition to showing all the totals by tag, I would also like to show the overall total. And this is an easy task because all we have to do is to create a var total duration equals to 0 before the loop. And then inside the loop, we can add total duration plus equal duration like this. And finally, after this loop, we can print the total for all the tags. And this is going to be equal to the total duration dot toString as fixed, so that we can format this number. And then we can add an h at the end, just like we did here. And now we can save and run the program one more time. And as we can see, we now get the overall total at the end. So this concludes this project on data processing. And now that we completed this, we have some new skills that we can use to read command line arguments and read data from text files. And because this is a command line app, all it does is to generate a text-based report. But as you make progress and learn about Flutter outside this course, you could use this code as a template and write your own apps that process CSV files and produce nice-looking charts. In any case, this project was a good way to build some confidence in manipulating strings and working with maps in Dart. Okay, so let's continue on the next section. In this section, we are going to talk about nullable and non-nullable types in Dart. And to better understand what this is about, we need to talk about null values. Earlier on in this course, we have seen that if we have a map and we try to access the value of a key that doesn't exist, then we get a null value. And this means that there is no value for this key. And as we write programs, there are many situations where it's useful to use null values. And as we have seen, we can use if statements to check if a value is null. For example, here we could type if person with age is null, then print age is missing, else print person with age, like this. And we can see that this program prints age is missing on the console. On the other hand, there are cases where null values are not necessary and not even desirable, because if we can guarantee that a certain expression or value is never null, then we don't even need to check for it. And some languages have a feature called null safety that makes it possible to decide at compile time if a variable can be null or not. And as of March 2021, null safety is available as a stable feature on version 2.12 of the Dart language. So what does this all mean for us? Well, up until now, I've been showing you the various features of the Dart language using Dartpad based on version 2.8.4 of the Dart SDK, which didn't include null safety. However, if you try to run any code with Dartpad today, then null safety will be enabled. This means that if we try to type int x equals null, like this, then we will get an error telling us that a value of type null can't be assigned to a variable of type int. And that's because variable types are non-nullable by default if null safety is enabled. So in this section, we will learn about nullability and null safety. And this is important because null safety is officially enabled for Flutter 2.0, which ships with Dart 2.12. But because Dart and Flutter are quite popular, you are still likely to encounter a lot of code that was written before null safety. So in this section, we will see what's changed with the introduction of null safety so that you'll be able to work with or without it. So let's continue on the next lesson. In this lesson, we are going to learn about nullable and non-nullable variables. As we do this, I'll be using two separate tabs of the Dartpad editor. One without null safety and one with null safety, so that we can learn about what's changed. So let's start with the older version of Dartpad using Dart 2.8, and over here we can type int a equals null. And as we can see, Dart tells us that we shouldn't explicitly initialize variables to null. In other words, if we want this variable to be null, we can just declare it like this without an initializer, and it will be initialized to null by default. On the other hand, if we move over to Dartpad with null safety, here we can type the same thing. And this time we get an error telling us that a value of type null can't be assigned to a variable of type int. And that's because if null safety is enabled, then this variable can't be null. However, if we really want to be able to assign null to this variable, then we have to declare it as nullable. And we do this by adding a question mark after the name of the type, like this. And now that we have done this, we can remove the initializer, and this variable will be set to null by default without any compiler errors. Now, suppose that we declare another variable called int b equals 2, and then we try to print a plus b. And as we can see, this generates an error that says an expression whose value can be null must be null checked before it can be dereferenced. Now, we will understand exactly what this error means in a little while, but the essence of this is that we can't add two variables if one of them is null. On the other hand, if we copy these two lines of code and go back to the older version of Dartpad and paste them over here, then we can see that we don't get any compile errors, even though A is null. And if we run this program, we get this type error, which is quite hard to understand. And what this actually means is that we can't use the add operator if one of the operands is null. And the important thing to understand here is that with this version of Dartpad, we only get an error at runtime when we execute our program. But if we use Dartpad with null safety, then we get a compile time error. And this is much better because the compiler can help us to write programs that are safer. So for now, we are just getting a feel for what it's like to have null safety. And null safety makes us productive because Dart can tell us when we are doing something wrong. And I can assure you that this is a great advantage, especially as we write bigger and more complex programs. In any case, I will point out all the places where we need to keep null safety in mind as we continue with the course. Okay, so let's continue on the next lesson. In the last lesson, we have learned about the difference between nullable and non-nullable variables. And we have seen that if we use Dart with null safety, we get some compile time errors when we are doing something wrong. In particular, we have seen that we can't add two variables if one of them is nullable. And this error tells us that this expression must be null checked before it can be dereferenced. And of course, if we made this variable non-nullable and give it a value, then this error will go away. But let's suppose that we really want this variable to be nullable and only print the result of a plus b if a is not null. To do this, we can type if a is null, and here we can print a is null, and then we can put this print statement inside an else, like this. And as you can see, the error now goes away, and that's because Dart is smart enough to know that this print statement is only executed if a is not null, and as a result we are allowed to add a and b. And to make this possible, Dart is using a special feature called flow analysis. And thanks to flow analysis, this variable that is nullable is promoted to a non-nullable variable inside the else branch. Okay, so let me clear all this code so that I can show you another example. And suppose that we have an int x equals 10. And here we can type int sign, like this. So this is a non-nullable variable because we haven't declared it with the question mark sign. But we have not initialized this just yet. So if we try to print sign, like this, we get an error because the non-nullable local variable sign must be assigned before it can be used. So let's fix this. And over here we can type if x is greater or equal than 0, then sign equals 1, else sign equals -1. And now we can see that the error goes away. And this is possible thanks to a feature called definite assignment. And the way this works is that Dart knows for sure that by the time we reach the print statement, then this variable is assigned. So this is very useful because it allows us to declare non-nullable variables and initialize them later. By the way, here I've written this code just to show you how definite assignment works. But we could have written code that behaves exactly in the same way by typing int sign equals x is greater or equal than 0, and then question mark 1 colon -1. So this is using the conditional operator and it does the same job as the if and else statement. But you may need to use an if and else statement if your conditional logic is more complex than this. So being able to declare a non-nullable variable and initialize it later is very valuable, and Dart makes this possible because it supports definite assignment. And once again, if we try to print the sign variable before it is definitely assigned, then Dart will generate an error. So the bottom line is that Dart uses flow analysis features to help us write safer code and more easily deal with nullable and non-nullable variables. Okay, so let's continue on the next lesson. It's now time to introduce the assertion operator that we can use to assign a nullable value to a non-nullable variable. To show you how it works, let me write some sample code and then I'm going to explain it. So over here I can type int x equals 42 and then int question mark maybe value. and then if x is greater than 0, then maybe value equals x, like this. So this is a variable that can hold a null value because it is only assigned if x is greater than 0. Then over here we can write int value equals maybe value, and then I'm going to add an exclamation mark like this, and then we can print value. So how does this code work? Once again, here we have a nullable variable that is only assigned if x is greater than 0, and then we try to assign this to a non-nullable variable. However, if we try to do this without using this operator, then we get an error telling us that a value of type int ? Can't be assigned to a variable of type int. In other words, we can't assign a nullable value to a non-nullable variable. However, if we are sure that this variable is going to have a non-null value, even though it's nullable, then we can say, hey Dart, I know what I'm doing and I want to assign this to a non-nullable variable. And we can do this with the assertion operator. So if we run this code, we can see that it prints the value 42. But if we change this to -1, then this code will generate an error at runtime, saying that we got an unexpected null value. So the takeaway of this lesson is that if you are sure that a nullable variable will be non-null when you run your program, then it's safe to assign it to a non-nullable variable with the assertion operator. But keep in mind that if you are wrong, then this will generate a runtime error. And for this reason, the assertion operator is also known as the bank operator. So let's continue on the next lesson. In the last lesson, we have seen how to assign a nullable value to a non-nullable variable with the assertion operator. And we have learned that if we use this incorrectly, we can end up with a runtime error. So in this lesson, I want to tell you about the if-null operator that you can use to deal with this kind of situation, but without risking any runtime errors. So suppose that we wanted to assign a value of 0 to this variable if maybe value is null. One way to do this is to use the ternary operator and type maybe value equals null ? 0 and then colon maybe value, like this. And if we run this code, we can see that the output is 0 because for x equals to -1, then this variable is null. So this works, but there is another way to write this logic with much less code, and that is to use the if-null operator. So how does this work? Well, over here we can delete all this code, and then we can just type maybe value ? And then 0, like this. And what this does is to assign this value to this variable if it's not null, but if it is null, then we assign 0 instead. So when should we use the if-null operator as opposed to the assertion operator? And the answer is that if you have a default value that you want to assign when this value or expression is null, then it makes sense to use the if-null operator. Instead, you should use the assertion operator if you are sure that this expression or value will never be null at runtime. And just to be clear, here I'm just showing you the various null safety features of Dart with simple examples. But as you write your own programs, then it is your job to work out what is the appropriate code to write. By the way, there is also a thing called augmented assignment if-null operator that you can use. That sounds scary, but it's actually quite simple, and it works like this. So we can type maybe value ? Equal and then 0. And what this does is to assign 0 to maybe value, but only if it is currently null. And as you can see, Dart now shows a warning here telling us that by the time we reach this line, then maybe value cannot be null, and is redundant to use the if-null operator here. So we can remove it. Okay, so let's continue on the next lesson. In the last few lessons, we have explored some of the null safety features of the Dart language. And one thing you may have noticed is that in this section, we have been explicitly declaring the types of our variables. But as we know, Dart has type inference, and normally we can use var, final, and const when we declare variables. However, type inference works best when we initialize variables when we declare them. So over here, we could declare this variable as const x equals -1, and Dart will infer its type to be int. Similarly, here we could declare this variable as final, and again, Dart will infer that its type is int. And In this case, we could also use type inference and declare this variable as var, because it is set more than once. But when we do this, it is a bit harder to figure out what is the type of maybe value, because it is not initialized when it's declared. So if you're not sure whether you should use type inference or declare variable types explicitly, I would recommend that whenever possible you initialize variables when you declare them. That way your code will be clearer and you can make the most of type inference. So what we said up until now about type inference still stands, and if you use null safety, Dart will automatically work out if a variable is nullable or non-nullable. Okay, so let's continue on the next lesson. Now that we are a bit more familiar with null safety, let's see how to use it when we work with collections. So here we could declare const cities equals, and then within square brackets, London and Paris, like this. And if we do this, Dart will infer that this is a list of strings. However, if we wanted, here we could add a null value. And because we haven't specified any type constraints, Dart is happy with this. However, look at what happens if we add a type annotation. So here we can add string within angular brackets, and now Dart complains that the element type null can't be assigned to the list type string. And this makes sense, because if null safety is enabled, then we are only allowed to add non-null strings inside this list. However, if we copy this line and move over to Dart path without null safety and paste it here, then this will not generate any errors, because null safety does not apply here. And we will see what implications this has in the upcoming lessons, but for now let's get back to Dart path with null safety, and here we had two options. The first one is to remove null from the list, and this will make Dart happy. However, suppose that we want to allow null values into this list. To do that, we could remove the type annotation, or even better, we can say that this is a list of nullable strings by adding a question mark here. And with this type annotation, both strings and null values are allowed inside this list. Next, let me show you what happens when we iterate on this list and try to do something with the values inside it. So here we can type for var city in cities. And let's suppose that we want to print each city in uppercase letters. So here we can type print city dot to uppercase, like this. As we can see, this produces an error saying that an expression whose value can be null must be null checked before it can be dereferenced. And if you remember, we have seen this error before. So to fix this, here we could type if city is not null, and then we can put the print statement inside curly braces. And by doing this, Dart is smart enough to promote city to a non-nullable value inside the if statement. Okay, so let's continue on the next lesson. In the last lesson, we have seen how to iterate on a collection that may contain null values, and we have used an if statement to only print the values that are not null. So this will work, but I want to show you a different way of doing things. So let's remove this if statement. And to deal with this error, we can add a question mark before the dot, like this. And as a result, this expression will return the uppercase version of this string if it is not null, and it will return null otherwise. As a proof of this, we can run this program, and we can see that the console prints London, Paris, and null. So this syntax is known as the conditional access operator, and we can use it to only call this method if this variable is not null. And this is a good example of how null safety helps us write code that is safer. As a proof of this, we can copy this code, and if we get back to the old Dart path without null safety, we can paste it here. And here we could remove the question mark and just use the standard dot notation to access this method. And as you can see, the Dart compiler doesn't produce any warnings for this code. But if we try to run this program, we get an error on the console, and this is telling us that we can't access the to uppercase method because one of the list items is null. So calling methods on variables that are null is one of the most common mistakes that programmers do, because we often forget to check this. In other languages, this error is known as a null pointer exception, and it is so common in software that it has been called the $1 billion mistake. Now, I should mention that the conditional access operator is also available in versions of Dart that don't support null safety, and we can use it to fix this code. But it is only with null safety enabled that Dart can tell us at compile time when we forget to check if a variable is null, and this is a great advantage. In summary, we have now seen how to work with collections that may have null values, and we have learned how to use the conditional access operator. Okay, so let's do a wrap up. So far in this section we have learned about all these features, but there are some additional ones that have been added to Dart in order to enable null safety. But before we can explore these in more detail, we need to introduce some new concepts, including functions and classes in Dart. So as we make more progress with the course, we will keep null safety in mind. Okay, so we have now reached the end of this section about nullable and non-nullable types. And if there was just one thing that you need to take away from this section, is that every time you declare a variable in Dart, think about whether it should be nullable or not. This may seem like extra work, but it will lead to better code, and Dart can help you along the way. By the way, now that we explored null safety in sufficient detail, I'd like to point out that Dartpad with null safety includes this drop-down over here on the right. And if you click here, you can find a list of exercises that you can use to practice null safety in Dart. So I encourage you to take these exercises, and if you want to explore this topic more in depth, you can check out my ultimate guide to non-nullable types, which is freely available on my website as well as on my YouTube channel. Okay, so let's continue on the next section. Functions are essential building blocks that we can use to better organize our code and make it more reusable. Functions are a broad topic, and for this reason we will cover them over two separate sections. So in this section we will start with the basics. As part of this, we will learn how to declare and use functions so that we can pass arguments to them and get a return value. We will understand the difference between named and positional arguments, and we will talk about default values and required arguments so that we can learn how to use functions correctly with null safety. And we will also learn about the arrow notation so that we can write functions in a more concise way. Then we will talk about the lexical scope and inner functions and the importance of avoiding global mutable state by writing pure functions. And after we have covered all the basic concepts, we will move to the next section where we will learn about more advanced ways of using functions in Dart. Okay, so let's get started. In this lesson, we are going to learn about functions. And so far in this course, we have always been adding all our code to the main method. But as programs grow, we want to organize our code and break it into smaller chunks. So just like we can use variables to store some values and reference them multiple times, we can use functions to encapsulate some code that we can reuse and call multiple times. So functions are essential building blocks that we can use to build more complex programs because they let us better organize our code and make it more reusable. So let's see how we can use them. Over here, below the main method, we can type void say hi, and then a pair of parentheses, and then we need to add some curly braces that will contain the function body, and inside here we can type print hi, like this, and then we can add another print statement that says welcome, like this. Then in the main method we can type say hi with a couple of parentheses and a semicolon, and if we run this program, we can see that the output has two lines that say hi and welcome. And if we want, we can call this function twice. And as we can see, when we do this, the output is hi, welcome, and then hi, welcome again. So the main takeaway here is that we have defined a simple function that contains some arbitrary code, and we can execute this code as many times as we want by calling this function. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about function arguments. To do that, let's start with a practical example. Over here, we can declare two variables that represent my name and age. So we can type const name equals Andrea, and then const age equals 36. And then we could add a print statement that says my name is, and then $name, and I'm, and then $age years old, like this. Now, suppose that we want to call this print statement multiple times with different variables. So, for example, here we could have const name2 equals Lucy, and const age2 equals 22. And then we could print my name is name2, and I'm $age2 years old. And then we can run this program, and we can see this output on the console. And as we can see, here we have some code duplication because these print statements are nearly identical and the only thing that changes are these variables. Code duplication is almost never a good thing, and to make this better, we can create a new function. So over here, below the main method, we can type void describe and then a pair of parentheses, and then we need to add some curly braces to define the function body. And this is where we can put the print statement. So to make our life easier, we can copy this line and paste it in here. However, when we do this, we get two errors telling us that the name and age are undefined. And the reason for this is that we have defined these variables over here in the main method, but this function doesn't know about them. So in order to make this work, we need to find a way to pass these variables to the describe function. To do this, we need to modify our function so that it takes two arguments. Here we can type string name and then comma and then int age. And as a result, the errors go away. And now we can call this function from the main method. So here we can replace this print statement with describe and then within parentheses name and age. And we can also do the same thing here and call describe with name2 and age2 like this. And if we run the program now, we can see that the output is the same. So when we call describe with these arguments, the name will be set to Andrea and the age to 36. And when we call it with these arguments, the name will be set to Lucy and the age will be set to 22. And the important thing to notice is that we have now removed the duplicated code that we had before by moving this print statement inside the describe function. Now, one great benefit of using functions is that if we want, we can change the code in the function body. For example, here we could remove this proposition and add a full stop like this. And if we run the program again, we can see that this is changed in both lines. And this would have been harder to do if we had multiple print statements in the main method, because we would have had to update each one separately. So functions help us to write more maintainable code because we can change the way a function behaves without changing the way we call it. By the way, if we want, we can also call this function like this: describe and then Tony, which is a string literal, and 30, which is an int literal, like this. So when we pass arguments to a function, it doesn't matter if they are variables, expressions, or literals, as long as they have the correct type and they are in the correct order. And if we make a mistake and we pass an argument of the wrong type, Dart will tell us that the argument type bool can't be assigned to the parameter type int. Similarly, if we forget to pass an argument, Dart will tell us that 2 positional parameters are expected, but only one found. Okay, so let me remove all these lines and we are just going to keep this one going forward. And before we continue, let me point out that we create functions in order to do something. For this reason, when we choose a function name, this should begin with a verb, such as describe. On the other hand, when we declare variables, we should use a noun, such as name or age. Okay, so let's continue on the next lesson. In the last lesson, we have seen how to declare a simple function that describes a person by name and age. Now, in this case, all this function does is to print a string to console. But in Dart, we can also create functions that return a value. For example, let's see how we can modify this function so that it returns this value as a string so that we can do something with it other than just printing it. So at the moment, we have this void keyword before the function name, and void means that the function has no return value. But if we want, we can change this to string. And as we can see, Dart now warns us that this function has a return type of string, but doesn't end with a return statement. To fix this, here we can remove the print statement along with the parentheses, and instead we can return this. So when we define a function with a return type other than void, then this function must return a value. And this value should match the return type of the function, otherwise we will get a compile error. Okay, so this function now returns a value, but we are not using it when we call it. And in fact, if we run this code, we can see that nothing is printed on the console. So in order to use the return value of the function, here we can type final person equals describe with these arguments, and then we can print person like this. And if we run the program again, we can see that this string is printed again. So by defining the describe function like this, we now have a reusable piece of code that we can use to describe a person by name and age, and we can use the return value any way we want. So this is a good function because it defines some code to perform a specific task. And as we make progress in the course, we will learn more about what makes a good function. So let's continue on the next lesson. In this lesson, we are going to do this exercise. Write a function called sum that takes a list of values as an argument, and this argument should have type list of double and returns the sum of all the values. Then call the function multiple times with different input values. For example, you should test it with an empty list as well as lists that contain some values, and then print the result. Okay, so you can try to solve the exercise yourself, and then we'll look at the solution. Okay, so let's see how to solve this. First of all, we want to declare our function, and because this will calculate the sum of values of type double, then the return type should be double. And then we can call this function sum, and then inside parentheses we can declare an argument of type list double, and we are going to call these values. Then we need to specify the function body. So to calculate the sum, we can iterate through all the items in the list and accumulate all the values. So let's write the code for this. We can start off by declaring var sum equals 0.0, and then we can add all the values inside a loop by typing sum plus equal value like this, and finally we can return sum. So this completes the implementation of our function, and I should point out that here we have declared this variable called sum, which has the same name as the name of the function. However, Dart is smart enough to know that this is a variable and this is a function, because functions always have parentheses, and so there is no confusion here. Okay, so let's test this function, and inside the main method we can type print, and then as an argument we can pass sum, and as an argument of sum we can pass an empty list, like this. And this syntax is valid because sum returns a value that can be passed directly as an argument to print. So if we run this program, we can see that the output is 0. Then we can try the same with a non-empty list that contains the values 1 and 2. And if we run the program, we can see that the output is 3. And we can add 2 more items, for example 3 and 4. And if we run again, then this time the output is 10. And this completes our exercise. So let's continue on the next lesson. In this lesson, we'll learn about named and positional arguments, which are 2 different ways of declaring function arguments in Dart. And to do this, we will use the describe function that we created previously. Now, this function uses so-called positional arguments, and the way positional arguments work is that we can declare them inside parentheses like this, and when we call the function, Dart knows that the first argument will be the name and the second argument will be the age. In other words, each argument is identified by its position in the argument list. Now, this function only has 2 arguments, so when we call it, it's relatively easy to work out the correct order. However, when we have functions with 3, 4 or more arguments, it becomes more difficult to call them correctly, and very often we call functions that are defined in different files. So if we only use positional arguments, it becomes harder to understand what each argument represents just by looking at the function call. To address this problem, Dart supports named arguments. So how do named arguments work? To define some named arguments inside a function, we need to surround them with a pair of curly braces, like this. And once we do this, Dart will show us an error telling us that we have too many positional arguments, 0 expected but 2 found. And that's because these arguments are now named arguments. And you can't pass a positional argument to a function that expects a named argument. So to fix this, we need to update our function call by adding the name of each argument before its value using this syntax. So here we can type name, colon, and then Andrea, and then age, colon, and then 36. And while this function call is a little more verbose, I feel that it's a lot more readable. In fact, it almost reads like plain English because person is equal to describe with name Andrea and age 36. So using named arguments is really about improving the readability of our code. By the way, before I continue, I want to point out that this code will not compile if you are using the null safety version of Dartpad. So if that's the case, you'll get some errors telling you that the parameter name can't have a value of null because of its type, and no null default value is provided. And to understand what this means and why it happens, we need to first talk about default and required arguments. So let's continue on the next lesson. In the last lesson, we have learned about named arguments. And one important thing to know about named arguments is that by default, they are not required. And this means that when we call this describe method, we can choose to omit the name or age arguments. For example, here I could remove the age argument, and if I run the program now, the output says my name is Andrea and I'm 0 years old. And the reason for this is that when we call this function and only pass the name argument, then the name variable will be set to a non-null value, which is my name, but the age variable will be set to null. In other words, omitting the age argument has exactly the same effect as calling this function with age null, like this. And the fact that named arguments can be omitted has some implications for null safety. So if we use Dartpad without null safety, then this code is valid, but we need to be careful about how we use these arguments, because they could be null. But if we use Dartpad with null safety, then this code doesn't compile, because when null safety is enabled, then all types are non-nullable by default. So in order to fix this code, we have three possible options. Option 1 is to make these arguments nullable by adding a question mark to the type declaration. And this is the right thing to do if we really want these arguments to be nullable. But in this case, this doesn't seem like a good solution, because we want these arguments to be not null when we interpolate them inside this string. So option 2 is to provide a default value for these arguments. To do this, we can remove the question marks, and then here we can type, for example, name equals to an empty string and age equals to 0. And these arguments will be set to these values if we omit them in the function call. For example, here we have omitted the age argument, and if we run this program, we can see that the default value 0 is used. On the other hand, the output uses Andrea for the name, because this was passed in the function call. So default values are a good strategy if you want arguments to be optional and you have a sensible default value that you can assign to them. But in this case, I don't think this is a good solution, because there isn't an obvious value that we can choose as a default for these arguments. And what we really want is to tell Dart that these named arguments are required, so that it's not possible to call this function unless we specify both arguments. And this leads to option 3, and that is to remove the default values and declare each argument as required, like this. And as we can see, when we make this change, the compiler error changes, and this time we see that the named parameter age is required, but there is no corresponding argument. And I feel that this message is a lot clearer than what we had before, because it tells us explicitly that we need to provide the age argument. And once we do this, then the error goes away. Okay, so let's do a recap of what we have learned. When you declare a function with named arguments, then those arguments will not be required and they can be omitted when you call the function. And if you use null safety, you need to either make the arguments nullable with a question mark so that they can be assigned with a null value, or make the arguments non-nullable. If you do this, you have to either provide a default value, which is not null, or mark the arguments as required. Now, you may feel that all these different rules are a bit complicated, but as we have seen previously, null safety is all about giving you some compile time guarantees about what can and cannot be null and help you write safer programs. Now, if you are using a version of Dartpad without null safety enabled, then the compiler will be a lot more tolerant, because all types are nullable by default. So you won't get any errors if you declare functions with named arguments and pass null values or omit the arguments entirely. But keep in mind that if you do this, your arguments can be null, and you should add some null checks if appropriate. By the way, the required keyword that we have used here is only available if null safety is enabled, so don't try to use it without null safety or you'll get some errors. And I should also mention that prior to null safety, it was still possible to mark a named argument as required using the so-called @required annotation. However, to test this properly, you need to use an IDE such as Visual Studio Code or Android Studio, as this annotation doesn't seem to be available in Dartpad 2.9. So let me remove this. For now, don't worry too much if all the content we discussed in this lesson is not completely clear. As we continue exploring functions in Dart, all these concepts will start to make sense, and I'll point things out as we make progress. Okay, so let's continue on the next lesson. In the last lesson, we have seen how named arguments can be omitted when we call a function, and because of this, we can provide a default value or mark them as required. And when we use positional arguments, things work a bit differently, because positional arguments are required by default. However, it is also possible to declare positional arguments that are optional. So let me clear this code and show you a new example. Over here, we can declare a new void function called foo, and then we can declare int a and int b as positional arguments. And inside, we can print these two arguments. And in the main method, if we call this function with just one argument, we get an error because this function expects two arguments, but we have only given one. However, if we want, we can make this argument optional by surrounding it with square brackets and even give it a default value. And if we do this, we can run the program, and as we can see, a is 1 and b is 2. And if we pass a second argument to this function with a value of 3, then this variable will be set to 3 inside the function. Now, if we take this code and try to use it on Dartpad with null safety, it works in the same way. However, if we remove the default value from here, then this code will not compile. And once again, this is because this argument is optional. And if we don't want to give it a default value, then we had to make it nullable. In summary, default values work in the same way whether you use named or positional arguments. And if you enable null safety and use them incorrectly, Dart will tell you what you are doing wrong. Finally, I'd also like to say that in Dart you can mix and match positional and named arguments. For example, here I could make this a named argument by using curly braces, and if we want, we can add additional named arguments as well. So as long as we list the positional arguments first, followed by the named arguments, then this is valid syntax, and we can call this function like this. Okay, so this is how named and positional arguments work in Dart, and we will get some more practice using them in the rest of the course. So let's continue on the next lesson. It's now time to do a new exercise. So over here we have this program that lists some pizzas along with their prices and can be used to calculate the total price when we make an order. So I'd like you to modify this program so that the total calculation can be moved to a separate function that can be called multiple times with different orders. This function should take the order as an argument and return the total. So this is a good example of a real-world scenario where you need to extract some existing code into a function. As usual, you can grab the starter code for this exercise from the course repo on GitHub. So try to solve this by yourself and then I'll show you the solution. Okay, so let's see how to solve this. And the first thing that we want to do is to declare a function to calculate the total. This should return a double and we could call it calculate total. And we can pass an order as an argument, and this would be a list of strings. And then we need to provide the function body. To do this, we can move all this code from here and into here. And then we can call the function by typing final total equals calculate total with order. However, we still have an error because we have defined the pizza prices variable inside the main method, and this is not visible inside the function. To fix this, we can either move this code inside the function or pass this variable as an argument to the function. And in this case, there is no right or wrong answer, but I would argue that it's better to move this code inside the function, as this represents a set of prices that are fixed and unlikely to change often. So let's go ahead and cut this code and paste it in here. And now this error goes away. Finally, Dart is kindly reminding us that this function doesn't have a return statement, so we can easily fix this. And now our code compiles, and if we run this program, we get the total for this order. And what is nice about this refactor is that we can more clearly see what is the input and what is the output of this function. So when you write your own programs and you have some code that solves a specific task, ask yourself if it should live inside a function, and if so, choose a good function name and decide what arguments it should take. Use named or positional arguments as appropriate so that it's clear from the context what the function does. Okay, so let's continue on the next lesson. Now that we are a bit more familiar with functions, I'd like to show you a new operator called the fat arrow operator. So let's see how this works. Suppose that we have a simple function that returns the sum of two numbers. We can declare our function like this, and we can define the function body with curly braces and a single return statement that returns x plus y. Now, because this function contains just one statement, there is a simpler way of defining its body, and that is to use the fat arrow notation. So how does this work? Over here, we can select the curly braces as well as the function body, and we can replace this entire block of code with this arrow notation and then x plus y, like this. So this function does exactly the same thing as it did before, but by using the arrow notation, we can remove both the curly braces and the return keyword. And this is great because it means that we can accomplish the same thing with less code. So as long as our function body has only one statement, you can use the arrow notation. By the way, this also works for functions that don't return a value. For example, here we could define a void print sum function, which takes two arguments, and we can use the arrow notation to print x plus y. And this also works because this function's body has only one statement. In summary, the arrow notation helps you to write more concise code, and we'll use this when appropriate throughout the course. So let's continue on the next lesson. In this lesson, we are going to learn about the lexical scope. So what is a scope exactly? A scope is a block of code that is defined inside curly braces, and a scope can contain multiple statements. For example, here we could declare a const a equals 10, and if we want, we can print a, because this print statement is inside the scope of the main method, which is where the a variable is defined. Now, if we want, here we can add an if statement that says if a is greater than 5, and then inside it we can declare const b equals 5, and if we want, we can print b inside the scope. But if we move this print statement outside the scope, then we can see that b is undefined, and that's because b belongs to this scope. On the other hand, it is perfectly valid to print a inside the if statement, because a is defined in the parent scope. So as long as we try to use a variable within the current scope or within a parent scope, then our code is valid. Not only that, but if we want, we can even declare multiple variables with the same name as long as they belong to different scopes. For example, here we could rename this variable to a. And when we do this, Dart will always use the variable that is defined in the closest scope. So if we run this program now, the output shows 10, which is the value that is printed by this statement, and 5, which is the value that is printed by this statement. Next, let's talk about the global scope. In addition to all the local scopes that we can define with curly braces, we also have a global scope that lives outside the main function. And we can use the global scope to declare variables, functions, enumerations, and other types. For example, here we could declare a const global variable equal to 15. And because this variable belongs to the global scope, it can be accessed anywhere. So if we want, we can print it here inside the main method. And as we are about to see, scopes are very important when we work with functions. Okay, so let me remove this if statement, and we can continue on the next lesson. In the last lesson, we have learned that each pair of curly braces defines a local scope, whether it's a function body or the body of a control flow statement. And up until now, we have always declared new functions outside the main method in the global scope. For example, here we can add a function called foo with one argument called b, And inside this function, we can print global because this variable belongs to the global scope. And we can print p because this is an argument for this function. However, if we try to print a here, we get an error saying that a is undefined. And the reason we get this error is that foo is declared outside the scope of the main method. However, one little known thing about Dart is that we can declare functions inside other functions. This means that we can move this function from here to here inside the main method. This makes foo an inner function because it is defined inside a local scope. And as a result, we can now print a because this function now has access to the enclosing scope. And just to be clear, this is a function declaration, and if we want to use it, we need to call it like this. And we can only call this from within the scope where it is declared. And if we want, we can take things even further and declare a void var function inside here, and this will have access to all the ancestor scopes, which means that we can print all these variables. Now, you may be wondering what is the purpose of inner functions and when you should use them. Well, if I had to be honest, I have been coding for many years and I haven't come across a good use case for inner functions. So inner functions are rarely used in practice, but I just wanted to show you how they work so that you can better understand the concept of scope. So let's continue on the next lesson. In this lesson, we are going to talk about global mutable state and functions with side effects. This is an important topic because global mutable state can lead to bugs and issues in your programs, and these can be hard to fix, costing you a lot of development time. So what is a side effect exactly? Well, let me show you with an example. Over here inside the global scope, we can declare a var counter variable equal to 1. And then we can add a void foo function, and inside this function we can print the star symbol times counter, and we can also increment the counter like this. And the important thing to notice here is that this function has access to this variable because it is declared on the global scope. Next, let's call this function inside the main method. So here we can call foo multiple times like this. And now we can run this program, and as we can see, every time this function prints a different value. And that's because this function increments the counter every time it is called. In other words, this function has a side effect because it modifies the content of a variable that is declared outside its own scope. And this is really bad because we are always calling the function in the same way, but we get a different result every time. And another way of saying this is that this function is not pure. So what is a pure function? A pure function is a function that always produces the same result when called with the same argument and doesn't mutate any variables outside its own scope. So in this particular case, the foo function doesn't have any arguments, and you may think that the main problem with this function is that it modifies the value of this counter. And maybe if we remove this increment from here, then this function will become pure. But that's actually not the case, because we can still modify this counter in other places, for example between each call to this function. And if we run the program now, we still get a different output every time. So the real problem with this program is that we have some mutable global state. And this means that anywhere in our program we can modify this variable, and this will affect all the code that reads that variable. Now, this is a very small program and it is easy enough to see where this variable is used. But if you have more complex programs with many mutable global variables in different files, it quickly becomes difficult to keep track of what changes and where. And in fact, adding mutable global state is one of the worst things that you can do to yourself and other developers. So the takeaway from this lesson is that you should never ever declare global variables like this. And as we will see, there are better ways of dealing with mutable state. And just to be clear, not all global variables are bad. In fact, sometimes it's useful to have some global constant values that you can refer to. For example, here we could declare a constant to represent how many bits are inside a byte. And we can use it to declare variables that depend on it. For example, we can declare a kilobit to be 1024 times bits in byte. And we can also declare a megabit like this. So having a named constant for this variable can be better than hard coding values like this. And the main difference between these two variables is that this one is mutable and can change value at runtime, and this one is constant and it cannot change at runtime. This makes it safe to use inside this program, even though it's a global variable. Okay, so this completes this section about the basics of functions. But we are just getting started, because in the next section we will learn some more advanced ways of using functions and take our knowledge to the next level. Okay, so let's continue in the next section. In this section, we will learn about some advanced ways of using functions. As part of this, we will learn about anonymous functions and closures, passing functions as arguments to other functions, function types, and then we will learn about some functional operators such as map, where, and reduce that we can use to work with collections. And we will see how to combine them together and write more effective code using a functional programming style. And we will also learn about generics, which are a powerful feature that we can use to write type-safe code and reduce code duplication, so that by the end of this section, we'll be able to really make the most of functions to write expressive Dart code. Okay, so let's get started. Up until now, we have been using named functions. That is, we have declared functions with a name, some arguments, and a return type. However, in Dart, we can also declare anonymous functions. As we will see, anonymous functions are very useful in many different scenarios. So let's see how we can declare an anonymous function which takes a string argument and uses it to return some other string. To do this, we can type open and close parentheses, and then inside it we can add a variable name, such as name. And then we need to provide a function body. To keep things simple, we can use the fat arrow notation and return hi and then name with string interpolation. So this is all we need to declare an anonymous function. So the code on the left represents the list of arguments, or indeed just one argument in this case, and the code on the right represents the function body. But since this function doesn't have a name, how can we use it? Well, one way to do this is to assign it to a variable. So over here we can type final say hi equals and then this function. So the important thing here is that by writing this, we are not declaring a conventional variable that will hold a value, but instead this variable will reference our anonymous function. And now that we have this, we can call our function. For example, here we can type print say hi and then pass Andrea as an argument. And what this will do is to pass this string literal as an argument to our function, and this function will return a string that is given as an argument to the print function. As a result, if we run this program, we can see that the output is hi Andrea. And just to be clear, when we use this variable as a function, we need to call it with parentheses and pass one argument. However, notice that if we omit the parentheses, then Dart doesn't complain. And if we run this code now, the output says closure main closure. And to keep things simple, you can think of a closure as an anonymous function. So if you have a closure or an anonymous function and you want to use it, you need to call it with parentheses and any arguments that it needs, like this. And by the way, I should point out that here we have declared this name argument without a type. This is quite common when defining anonymous functions, as they are typically quite small, but it is perfectly valid to declare this argument with a type, like this. And by writing arguments like this, the type system can help us avoid type errors. So when you read Dart or Flutter code in other projects, be aware that this kind of syntax defines an anonymous function. And if you want, you can write your own anonymous functions, and we'll see a few examples of this as we make progress. Okay, so let's continue on the next lesson. Now that we know what anonymous functions are, we can dive a bit deeper and learn about functions as first-class objects. As we have seen in the previous lesson, once we have an anonymous function, we can assign it to a variable. Not only that, but if we want, we can even pass a function as an argument to another function. Let me show you how. Over here, we can declare a new void welcome function, and I want this function to take another function as an argument. To do this, I can type string and then function with a capital F, and then string, which is an argument type, and I'm going to call this greet. So pay attention here. What I have just done is to declare an argument called greet, and this argument is a function that takes a string argument and returns a string. Then I can add a second argument called string name, and inside the function body I can type print, and then I can call greet and pass name as an argument, and then I can add another print statement that says welcome to this course. Then in the main method I can remove this print statement and type welcome, and then I can pass say hi and Andrea as arguments. And now if we run this code, we can see that the output is hi Andrea and welcome to this course. Now notice how this argument needs to be a function that takes a string argument and returns a string, and this anonymous function takes a string argument and returns a string. So because the type of this anonymous function is the same as the type of this function argument, then Dart is happy. And if the types didn't match for any reason, for example, if we declared this argument to be of type int, then we would get a compiler error. So let's change this back to string. So what this code is showing us is that we can assign functions to variables, and we can also pass functions as arguments to other functions by using this syntax. Now, you may be wondering what's the point of all of this? After all, we could have implemented the welcome method by just printing the name with string interpolation, like this. And if we do this, then we don't need any anonymous functions or function arguments. And I completely agree with you. For this example, we don't need these features. However, what I'm doing right now is to introduce some new concepts so that you can better understand some of the upcoming lessons, and soon enough I'll show you some real-world use cases that make use of this. So for now, just stick with me, and I promise that it will be worth it. Okay, so let's remove this print statement and we can continue on the next lesson. Now that we have seen how to pass functions as arguments to other functions, it's a good time to talk about function types. You see, when you declare function arguments like this, our argument list can become quite long and hard to read. So it would be nice if we could somehow define a named function type to improve the readability of our code. So let me show you how to do this. Over here at the top, we can type def, and then greet with a capital G, and equal to string, and then function, and then within parentheses string, with a semicolon at the end. So what this code does is to define a function type, and we can tell that this is different from a regular function because it doesn't have a function body. And now that we have this, we can update our welcome function and change the type of this argument to greet, like this. So this function type that we have just defined with a type def is known as an alias. And an alias is nothing other than a name that we give to a function type so that it can be reused. And as a result, we can use this type alias here to make our code more readable. But there are also other advantages. For example, let's say that we wanted to write different functions for saying hi in different languages. To do this, we could create a string function called sayHi, which takes a string name and returns hi name. And then we could define a similar function that says say bonjour string name, and this would return bonjour name. And maybe another one that says string say hola with a string name argument, and this would return hola name. Now all these functions are different, but they all match this greet type because they take a string argument and return a string. And this means that we could pass any of these functions as an argument to the welcome function call. As a proof of this, here we could call welcome with say bonjour and Andrea. Or if we prefer Spanish, we could type welcome with say hola. And if we run the program now, we can see that the console says hola Andrea. And I think this code really shows the flexibility of functions in Dart. So when is it a good idea to name a function type like this? And when is it better to write out the function type inside an argument list like we had it before? Well, if you need to use a certain function type more than once, you can write a type def like this and then use it as a function type inside the argument list. This way you can give a meaningful name to the function type, like we have done here. But if you need a new function type just once, then you don't need to name it, and in any case you can always refactor it into a typedef later. By the way, I should mention that there is a shorter version of this syntax that looks like this: typedef, and then string greet, and then a string name as an argument and a semicolon at the end. So this syntax is similar to this one, with the difference that you define the name here rather than here, and that you need to give a name to all the arguments. So it's up to you whether you want to use this syntax or this one, but I prefer the first variant because it makes it clear what is the type name and how the function is defined. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about closures, which are very closely related to anonymous functions. To show you what I mean, let's consider this example. Over here, we can declare a const multiplier equals to 10, along with a list of integers, like this. And then we can type final result equals list.map. And here we can use the x argument to return x times multiplier, like this. And then we can print the result. Now, we are already familiar with this kind of syntax because this is an anonymous function that we can use to multiply all the items in the list by this value. However, I'd like to point out that this anonymous function uses a variable that is defined outside its own scope. And to make this clearer, here I could replace this notation with a pair of curly braces and add a return statement like this. So in this example, the variable x is accessible only in the function body of this anonymous function, but the multiplier belongs to the parent scope. And when we declare an anonymous function that uses some variables that are defined outside its own scope, then that function is called a closure. Now, in practical terms, this is quite a subtle distinction, and you don't really need to worry about this. In fact, many people, including myself, often use the term anonymous function and closure interchangeably. But I just wanted to tell you what the difference is so that you know what I'm talking about when I use these terms. In summary, we have now learned about anonymous functions and closures, functions as arguments, and function types. And all these concepts are a little bit more advanced than just the basics, but they allow you to write code that is more effective. And they are also important because there are many APIs inside the Dart and Flutter SDKs that define function types. And as we will see later on, we can write code that is more composable by using the builder design pattern. And this is a pattern that is much easier to implement by using functions as arguments. Okay, so let's continue on the next lesson. Now that we have learned about anonymous functions, functions as arguments, and function types, we are ready to explore some useful operations that are possible with collections. In particular, we are going to learn about the for each, map, where, and reduce methods. And as we do this, we will also learn about generics, which are a feature of the Dart language that we can use to increase code reuse. And by the way, you might have already encountered some of these methods in other programming languages, where they are called map, filter, and reduce. And when I refer to these methods, you may also hear me using the term operators, because that's what they are, operators that work on collections. Okay, so let's start with an example. Suppose that we have a list of values that we can declare as const list equals 1, 2, 3. And we already know that if we want to print each value line by line, we can use a for in loop, which looks like this. For var value in list, and then inside the for body, we can print the value like this. And if we run this, we can see that the values are printed line by line. But if we want, we can accomplish the same thing by using the for each method. So take a look at this. Over here, we can type list.forEach. And as we can see, the auto-completion option shows us that this method takes an argument, which is a void function that takes an int argument. So what we need to do is to define an anonymous function with this type. So here we can add a couple of parentheses and add an argument named value. And then we can use the fat arrow operator and print the value like this. And if we run the code now, we can see that the output is 1, 2, 3 for this statement and 1, 2, 3 again for the for loop. And just to be clear, here we can choose any name we want for this argument. For example, we could rename this to x as long as we update it in the body of the anonymous function. And this helps making our code more concise. So this is how the for each method works, and you can use it as an alternative to a conventional for loop if you need to do something simple like this. On the other hand, if you want, you can write this function body inside curly braces, and by doing this, you can add more than one statement. Though keep in mind that if you do this, then perhaps a for loop is more readable, because it makes it explicit that we are running some code for all the values in this list. So let me revert this change. By the way, I'd like to remind you that functions can be passed as arguments to other functions, as long as they have the same type. So if we want, here we can simplify this statement and just call list.forEach and then passing print as an argument. Now, you may be a bit surprised to see that this code is valid, because for each takes a function that takes an int argument, meanwhile the print method takes an argument of type object. And in order to explain why we can do this, we need to first talk about classes, which is a topic that we will cover later in the course. But for now, keep in mind that when you call for each, you can either define an anonymous function like this and pass it as an argument, or you can pass an existing named function as an argument, provided that it has a compatible type. So these two statements do exactly the same thing, because in this case, Dart is implicitly passing the function argument that is provided by the for each function to the print statement. Okay, so let me clean up some of this code and we can continue on the next lesson. In this lesson, we are going to learn about the map operator, and the purpose of the map operator is to take a collection, perform a transformation on all its items, and return a new collection. For example, given this list of values, we could use map to generate a new list that doubles all the values of the items. To do this, we can type list.map. And the map method works in a similar way to the for each method, because it takes a function argument that is used to map each of the items inside the list. So here we can type value and use the arrow operator to return value times 2. Now the map operator returns a new collection. So we can assign the result to a new variable like this. And then we can print this, and if we run the program, we can see that the output is 2, 4, and 6. And just for comparison purposes, let's see how we can write this same logic using a regular for loop. Over here, we have to initialize an empty list, and then we have to write a for loop that iterates through all the values in the list. And then inside the loop, we can add each value like this. And as you can see, this is a lot more code than the version that uses the map operator. And this makes map very powerful, because we can use it to apply any transformation we want to a collection with very little code. So let me remove this code and continue on the next lesson, where I want to talk about map a bit more in detail. If we reveal the documentation for the map method, we can find that this is a function that returns an iterable of type t. And we can see that t also appears here and here as the return type of this function argument. So what is an iterable, and what does this syntax mean? An iterable is a collection of elements that can be accessed sequentially. So when we use a method such as map that returns an iterable, we can assign the result to a variable, and we can iterate on that variable using a for loop. And I should point out that when we print an iterable, then all the items appear inside parentheses rather than square brackets. Now, in Dart, lists and sets are both iterable types. So if you play a bit with the various methods that are available with lists and sets, you'll find that many of them work with iterables. And if we read the documentation of the map method, we can see that it returns a new lazy iterable. And what we mean by lazy is that this anonymous function is not evaluated until we use the resulting iterable, for example by printing it. This is a performance optimization to ensure that all the resulting items are only calculated when they are needed. So if you have a collection with thousands of items and you call map on it, then nothing will happen until you use the result. However, keep in mind that strictly speaking, the return type of map is an iterable and not a list. To show you what I mean, I'm going to move over to the null safety version of Dartpad, and here I could try to declare this variable as list of type int. And as we can see, this brings up an error telling us that a value of type iterable int can't be assigned to a variable of type list int. And if we want to guarantee that this expression is of type list, then we should add dot to list after we call the map method, like this. By doing this, all the items will be computed right away and this variable will be of type list. And before we can fully understand the relationship between list, set, and iterable, we need to talk about classes and inheritance, which is a topic that we will explore later in the course. For now, the important thing to remember is that many of the methods that we use to transform collections return an iterable, and if we want to get a list as a result, we need to use this syntax explicitly. Okay, so let's continue on the next lesson. In the last lesson, we have learned about what is an iterable, but we still haven't figured out what it means to use this syntax with angular brackets. Now, this T is known as a generic type, and generics are a feature of the Dart language that we can use to write type-safe code and reduce code duplication. So in this lesson, we are going to take a deep dive into anonymous functions and generics, and as a warning, this material is fairly advanced. But as usual, I'll guide you step by step. So let's start by taking a step back and consider how we could write a function that can double all the items inside the list using a for loop. This function would return a list of type int, and we could call it double items, and it would take a list of int values as an argument. And as we have already seen, we can calculate this by creating an empty list of type int, and then inside a for loop we can add all the values like this, and finally we can return the result at the end. And now we can comment out this line, and if we want to use this function we can type final doubles equals double items, and we can pass list as an argument. Now this code works, but we can only use it to double the values inside a list of integers. But what if we wanted to triple each value, or maybe calculate the square? Well, to solve this problem, let's make a copy of this function, and then we can rename this to transform. And then we can create a new function argument that we will use to transform each item in the list. So here we can add a new function argument that returns an int and takes an argument of type int, and we're going to call this f. And then inside the loop we can replace x times 2 with f of x. And this is quite powerful because what we have just done is to delegate the transformation of each item in the list to a function argument, and this makes our transform function a lot more reusable. And now we can update this call to transform with list, and then we need to pass an anonymous function which gives us x as an argument and returns x times 2. So this way we can specify how we want our items to be transformed with this anonymous function. And this is great because we can now repurpose this function. For example, we could copy and paste this line, and here we could replace the function body with x times x, and we can call this variable squares. So this is a good example of how we can use anonymous functions to make our code more reusable. However, this function only works with lists of type int, and if we define a new list of doubles like this, then we can't pass this as an argument to the transform function, because we will get an error telling us that the argument type list of double can't be assigned to the parameter type list of int. To solve this problem, we need to update this function to work with a generic type. So when we want to define a function that uses generics, we have to specify a generic type after the function name, like this. And by convention, generic types always use capital letters of the alphabet, like this. And now that we have this, we can use t instead of int wherever we need it. This means that the return type can be list of t, and the items argument can be a list of t, and this function argument can return t, and take an argument of type t as well. And this list literal should also be of type t. So when you convert a function to use generics, make sure that you update all the types accordingly. Now, if we are using the null safety version of Dartpad, we will get a couple of errors at this stage, because using a generic type t doesn't guarantee that t is not nullable. And with null safety, we can't multiply numbers that may be null. However, we know that these lists contain non-nullable values, and we can give Dart a little hint by annotating this function call with int like this, and this function call with double like this. So by adding a type annotation, we can be sure that our code is type safe, and we can see explicitly that this function can be called with arguments of different types. Now, there is still a problem with defining this function like this, because the input type is a list of t and it must be the same as the output type. This means that we can't use this function to round a list of doubles to a list of integers, for example by returning x.round over here. And this will generate an error that says the return type int isn't a double as required by the closure's context. So how can we make this function even more generic so that the type of the input can be different from the type of the output? Well, the solution is to add one additional generic type. So over here we can type comma capital R to define a new return type that is different from t. And then we can update the function so that it returns a list of R, and also use R as the return type of this anonymous function. And this result variable should also be a list of type R. Now, once we do this, our function is updated, but Dart complains because it now has two generic types, but we are only passing one. So here we need to be explicit and specify both the input and output type that we want. So in this case, we want to transform items of type int into items of type int. And in this case, we want to transform items of type double into items of type int, like this. And just for consistency, I think we should rename this variable to rounded. Okay, so this has been a long lesson, but we have learned some very important concepts that we can use to write more effective code. So let's do a quick review. We have started with a function called double items that we can use to double all the items inside a list of integers. Then we have created a more reusable version of this function using an anonymous function so that we can transform the items in the list in any way we want. And then we have introduced generics so that this function can operate on values of any type. And as a proof of this, we have used it to round a list of doubles into a list of integers. In fact, this transform function that we have just written does exactly the same thing as the map operator that we have covered previously, with the only difference that this function takes the input list as an argument, while map is a method that we can use on collections using the dot operator syntax. But from a functional point of view, both transform and map do exactly the same thing. Okay, so we've come a long way since we started learning about functions, and the main takeaway here is that we can use anonymous functions and generics to take code reuse to the next level. Now, some of these concepts are fairly advanced, so don't worry if you don't understand everything right away. In any case, we'll continue to use anonymous functions and generics as we make progress, so that you can become more familiar with them. So let's continue on the next lesson. Now that we understand how the map operator uses generics under the hood, we are ready to learn about some additional methods that we can use to work with collections. And in this lesson, we'll focus on how to filter and find items inside a collection using the where and first where methods. To get started, we can create a simple list that contains the values 1, 2, 3, and 4. And then we can try to get all the even numbers inside this list. To do this, we can type list.where. And as we can see, this method takes a function argument that returns a Boolean value and takes an integer argument. So to use this, we can type value, and then we can use the arrow operator, and then we can return value modulo 2 equals to 0, like this. And this expression will return true if value is an even number. And now that we have this, we can add final even equals the result of this expression. And then we can print even, like this. And if we run this code, we can see that we get an iterable with the values 2 and 4. In summary, the where method gives us a way of performing some filtering operations on a list without having to write a for in loop manually. Next, let's look at another method that is often useful, and this is called first where. We can use first where to get the first item inside a list that matches a certain condition. For example, here we could type final value equals list dot first where, and as we can see, this method takes two function arguments. The first argument is a condition that is evaluated on the items of the list, and the second one is a function that we can use if none of the arguments match this condition. So when we call this method, we can type x within parentheses, and we can use the arrow notation to check if x is equal to 5, for example. However, we can see that 5 is not on this list, and this means that this condition will never evaluate to true, but we still need to return something. For this reason, we can pass a named argument called or else, and this is an anonymous function that doesn't have any arguments, and we can use this to return a value. For example, here we could return -1. And we can add a print statement so that we can see how this works. And if we run the program now, we can see that the output is -1 because first where could not find any values equals to 5 on this list. But if we change this condition to x equals 4 and we run again, then the output is 4 because this value is on the list. And it is returned when we call first where like this. In summary, where and first where are some useful methods that we can use to filter and find items inside a collection. And we can provide our own custom filtering logic by using an anonymous function that returns a Boolean value. And this expression is also known as a predicate. Okay, so let's continue on the next lesson. In this exercise, I'd like you to implement a where function that works in the same way as the one from the Dart SDK. This function should take two arguments, a list of items and a function argument that can be used to filter items in the list by evaluating each item with a Boolean condition. This function should return a new list which contains the items filtered using the function argument. You should use generics so that the where function can work on lists of any type. Then use this function to retrieve all the odd numbers from this list that contains the values 1, 2, 3, and 4 and print the result. I recommend that you use Dartpad with null safety to complete this exercise. So take your time to complete this and then I'll show you the solution. Alright, so let me show you how to solve this. First of all, we want to declare the where function and we will write it using generics. So this function should return a list of type t, and it should be called where and take a generic t type. The first argument should be a list of type t called items, and the second argument should be a Boolean function that takes an argument of type t, and we can call this function f. Then we need to implement the function body. To do this, we can declare a result variable that will be used to store all the items to be returned. And we can initialize this to an empty list literal of type t. Then we can write a for loop on the input items, and inside the loop we want to check if this function returns true for a given item. And only in this case we add the item to the results. And then we return the results at the end. So this completes the implementation of the where function, and now we can use it. So first of all, we can declare a const list that contains the values 1, 2, 3, and 4. And then we can type final odd equals where. And here we can pass the list argument, and for each value on the list, we can return value modulo 2 equals 1. And as we can see, this code produces an error telling us that an expression whose value can be null must be null checked before it can be dereferenced. And as we have seen before, we can fix this error by explicitly adding a type annotation of int when we call the where function. And then we can print odd. And if we run the program, we can see that the output says 1 and 3, which are the odd numbers on this list. Okay, so let's continue on the next lesson. In this exercise, I'd like you to implement a first where function that works in the same way as the one from the Dart SDK. This function should take 3 arguments: a list of items, then a function argument that can be used to find an item in the list by evaluating each item with a Boolean condition, and a named function argument called or_else that is used to return a given value if none of the items in the list matches the search condition. This function should return the first item that matches the search condition, or the value returned by the or_else function if no matches are found. You should use generics so that the first where function can work on lists of any type. Then use this function to find the value 5 from this list containing the values 1, 2, 3, and 4. The function should return -1 in this case, and I recommend that you use Dartpad with null safety to complete this exercise. So try to solve this exercise by yourself, and then we'll do it together. Okay, so let me show you how to solve this. First of all, let's implement the first where function using generics. This function should return just one item and not a list of items. So the return type is t. And then we can type first where with a generic type t. And the first argument will be the list of items. The second argument is a Boolean function that we can use to evaluate each item. And to make this function easier to use, here we can add some curly braces so that the last argument will be a named argument. And inside here we need a function that returns a fallback value if this condition is not true for any of the items. This function has no arguments and is called or_else. And here we can mark this function argument as required, so that we can be sure that this argument is always given when we call first where. And then we need to implement the function body. So here we should use a for loop to iterate through all the items in the list. And inside the loop, we want to check if this function returns true for a given item. And if that's the case, we want to return that item. And then after the loop, we can return or_else. And we only reach this line if the condition was false for all these items. And note that here we are calling or_else with parentheses, because this is a function. Okay, so we have now completed the implementation of our function, so let's see how to use it. To start off, we can declare a list variable that contains the values 1, 2, 3, and 4. And here we can type final result equals to first where, and then we can pass list as the first argument, and then we need an anonymous function to evaluate the items in the list. This gives us an argument that we can call x, and we can use this to check if x is equal to 5. And then we need to provide the or_else argument. This is an anonymous function with no arguments, and we can use it to return -1. And finally, we can print the result. And if we run this code now, we can see that the output is -1 because 5 is not on this list. And if we change this condition to x equals to 3, then we can run the program again, and this time the output is 3. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about the reduce method. Reduce is very useful when you want to combine all the items inside a list based on some criteria and produce a single value as a result. A very common example of this is to use reduce to calculate the sum of all the items inside a list without using a for loop. So let's see how to do this. To start off, we can create a list that holds the values 1, 2, 3, and 4. And over here, we can type list.reduce. And as we can see, this takes a function that has 2 input values and 1 output value. And the way we can use this function is by combining all the values inside this list. So to get the sum of all the values in the list, we can specify 2 arguments called value and element, and we can use them to return value plus element, like this. And then we can assign the result of this expression to a variable, and then we can print it. And if we run this program, we can see that the output is 10, which is 1 plus 2 plus 3 plus 4. Now, the way reduce works is that it takes the first item inside the list and assigns it to a variable, and then it combines this with all the remaining items in the list using the combine function provided. Now, just by looking at this code, it is not obvious how these arguments change as we iterate through the items. So to better understand this, let me add some comments. At the beginning, reduce takes the first item in the list and assigns it to this value variable. Then it starts iterating and it takes the second item in the list and assigns it to the element variable. And then it calls the combine function with these values. And since here we return value plus element, then the result of this expression is 3, and this is used to update the value. So this is now 3, and the next item on the list is used, in this case the number 3. Then the combine function is called again, and because 3 plus 3 makes 6, then this value now has the value 6. And then we get the last item on the list, which is 4, and then we call combine one last time. This will add 6 and 4 and return 10 as the final result, which is the sum of all the items in the list. So the reduce method is useful when you want to combine all the values inside a collection without using a for loop. Though, as we have seen, it's a bit harder to figure out how the items are processed. So I invite you to use the reduce method if you're comfortable with it. Otherwise, it's perfectly fine to use a standard for in loop. Okay, so let's continue on the next lesson. Now that we have learned about map, where, reduce and other functional operators, I'd like to show you how we can combine them together to more easily process a collection of values. For example, suppose that we have a list of email addresses that we could declare as abc@abc.com, me@example.co.uk, john@gmail.com, and katie@yahoo.com. And then suppose that we have a list of known domains, for example gmail.com and yahoo.com. And what we would like to do next is to extract all the unknown domains from this list of emails. That is, we would like to get a list that contains the values abc.com and example.co.uk, because these are the domains that are found on this list and do not belong to this list of known domains. To do this, we can use some of the functional operators that we have learned. So let me show you how. Over here, we can type final unknown domains equals emails. And then on the next line, we can type .map. And here we can use the email argument to return email.split with an @ symbol .last. So given an email in this format, what this expression does is to split it into two components using @ as the separator, and then we can use .last to return the right hand side. So if we print unknown domains and we run this program, then we get all these domains in the output. But what we actually want to do is to only return the domains that don't belong to this list. And to do this, we can chain another functional operator at the end of this expression. In other words, here we can type .where, and then we can use the domain to return not known domains .contains domain, like this. And note how here I've chosen to name this variable domain, because we are applying the where operator to the result of the previous step, which returns a list of domains. So contains will be true if a given domain belongs to this list. And here we can negate this condition so that this expression will return false if the domain belongs to this list. As a result, this line will filter out all the known domains. And if we run the program now, then we can see that the output is what we want. And the reason that all this code is valid is that each one of these operators returns an iterable object. And because iterables support all these functional operators, then we can chain them up in sequence using the .access operator. By the way, if we want, we can even move all this logic inside a separate function so that we can reuse it when we need it. To do this, we can declare a function that returns an iterable of type string. We could call this getUnknownDomains, and this will take two arguments, a list of emails and a list of known domains. And because all this logic can be written as a single expression, then here we can use the arrow operator, and then we can take this code from here and paste it here. And then we can call this function and pass the emails and known domains as arguments. By the way, if we want, we can implement this same function using for loops and if statements. However, the resulting code becomes a lot more complex. In fact, this is how the alternative implementation looks like. So you don't need to copy all this code by hand, because I'm not going to explain this in detail. The point that I'm trying to make is that here we need to declare a variable that we can use to accumulate the results, and then we need an if statement inside a for loop with some custom logic, and then we need to return the result at the end. And because here we have many different statements, then we can't use the arrow notation, and we need to use curly braces and a return statement at the end. So using this functional style of programming can save us a lot of work and make our code easier to write and easier to read, because we can understand what each individual step does. On the other hand, this imperative style is harder to work with, because we had to write a sequence of steps and use control flow statements in order to produce the result that we want. And just to be clear, I'm not saying that functional programming is always better than imperative programming. But as you make progress in your programming journey, try to keep in mind that both styles exist and choose the one that makes your code easier to read on a case-by-case basis. And as we have just seen, the functional style works great when we need to manipulate collections like this. Okay, so this completes our overview about functional operators in Dart. And up until now, we have learned about for each, map, where, first where, and reduce, as well as how to combine them. But of course, there are many other operators that you can use to work with iterables using a functional programming style. And I invite you to become familiar with these other operators by looking at their documentation and try to use them with some examples. Once again, knowing about all these operators can save you a lot of time, because this programming style can be easier to write and easier to read compared to writing a lot of for loops and if statements by hand. Okay, so this completes this advanced section about functions, so congratulations for making it all the way to this point. Along the way, we have covered a lot of material, and I hope that you'll be able to apply this knowledge and improve your coding style. In any case, if you don't fully understand some of the concepts we covered, don't worry. We will keep using functions in the rest of the course, so you'll have many opportunities to get more familiar with them. So let's continue on the next section. In this section, we are going to learn about classes in Dart. Classes are at the foundation of object-oriented programming, and they are supported in many programming languages. So in this section, we will cover all the basics, including how to create classes and work with constructors, including const constructors and named constructors. We will see how to add variables and methods to our classes, and how to use getters and setters. We will also learn how to create class variables and methods using the static keyword, and how to make things private when needed. But there is much more than this, so in the next section we will talk about class inheritance and some more advanced concepts. Okay, so let's continue on the next lesson. In this lesson we are going to learn about classes. Classes are very important in programming. In fact, classes are supported in many programming languages, and we can use them to define new types. Up until now, we have been using some basic types such as bool, int, double, and string. And we have also learned about collection types such as list, set, and map. These types are very useful in many cases, but they can't always be used to model the data we need. For example, suppose you want to model a bank account, or a shopping cart, or a geometric entity such as the line between two points. These are complex concepts that are hard to model using the conventional built-in types. And we can use classes to model these concepts. And I like to think of classes as containers that hold some data, as well as the functionality for manipulating that data. As we will see, classes are at the basis of object-oriented programming, and they give us a good way to encapsulate the state of our programs. So let's get started with some code, and to do this we are going to use the null safety version of Dartpad. Okay, so let's create a new class that we can use to model a bank account. To do this, here we can type class and then bank account with a capital B, and then we can use curly braces to define the body of our class. So what should go inside here? Well, the most important thing about a bank account is the current balance. So let's declare the balance as a variable of type double. And since we are using null safety, here we need to initialize this variable with a value, because this type is non-nullable. So let's initialize it to 0, as that is the initial balance that we get when we open a bank account. Okay, so we have now created this very simple class, but how can we use it? In order to use a class, we need to create a so-called instance of that class. So if we move over to the main method, here we can type final bank account equals bank account with a pair of parentheses at the end and a semicolon. So what we have just done is to create an instance of this class. And now that we have done this, we can do something with it. For example, we can print the balance by typing print bank account dot balance. And if we run the program, we can see that the output is 0. And the way this code works is that first we create an instance of a bank account like this, and then we can access the variables that are declared inside that class by using the .access operator. And just so you know, the variables that are declared inside the class are also known as member variables or properties. So we could say that the balance is a property of the bank account class. Now, in addition to reading the value of a property, we can also set it. For example, here we could type bank account dot balance equals 100. And if we add another print statement and run the program, we can see that the balance goes from 0 to 100. Okay, so let me remove this first print statement. And next, I'd like to point out that if we want, we can create multiple instances of a given class. For example, here we could declare a final bank account 2 equals bank account. And then we could set the balance to 50 and also print it. And if we run the program now, we can see that the output is 100 for the first bank account and 50 for the second bank account. And that's because we have two completely separate instances of this class. So the bottom line here is that you can create classes to represent new types, and once you have a class, you can create as many instances as you want of that class. Okay, so let me remove this additional instance and we can continue on the next lesson. In the last lesson, we have seen how to declare a bank account class and how to modify its balance. And in this example, we have set the balance by assigning a specific value. However, in the real world, this is not how a bank account works. Because with real bank accounts, what we normally do is to deposit some money into it or withdraw some money from it. So it would be nice if we could model this behavior so that our class behaves more like a real world bank account. And to do this, we can add some instance methods. So over here, we can type void deposit and then within parentheses, double amount. And then we need to provide a method body. So inside here, we can type balance plus equal amount. And then inside the main method, we can remove this assignment. And instead, we can type bank account dot deposit 100. And if we want, we can even deposit one more time with a value of 50. And if we run the program now, we can see that the output is 150. Because the deposit method works by adding funds to our account every time we make a deposit. Okay, so in addition to this, it would also be nice to be able to withdraw some money. So to do this, we can add another method that says void withdraw with double amount. And inside the body, we can type balance minus equal amount. However, a real bank account would not let us withdraw an amount that is greater than the current balance. To model this behavior, here we can add a condition that says if balance is greater than amount, and then we can withdraw only if this condition is true. In addition to this, it would be also useful to know if this operation is successful, and one possible way of doing this would be to change the return type of this function to bool, and then if the withdrawal is successful, we can return true, otherwise we return false. Okay, so let's use this new method. And in the main method, we can remove this print statement and then we can type final success1 equals bank account dot withdraw with 100. And then we can print success equal to success1 with string interpolation and then balance equals and then within string interpolation bank account dot balance like this. And then we can copy and paste these two lines to simulate a second withdrawal, and we can rename this variable to final success2, like this. And if we run the program now, we can see that the first withdrawal was successful, but the second wasn't. Okay, so our bank account class is now starting to behave more like a real bank account. and that's because we have added some methods to model the behavior in the real world. Now, in this example, we have decided to use a Boolean return value to indicate whether the withdrawal is successful or not. In practice, it would be a bit nicer if we could somehow handle this error in a more meaningful way, so that we can tell whether the operation has failed because we had insufficient funds or some other error occurred. And as we will see later on in the course, this can be done by using exceptions. But for now, we can stay on track and keep this as a Boolean. Okay, so let's continue on the next lesson. In the last lesson, we have made some improvements to our bank account class. However, it would be nice if we could specify an initial balance when we create a new bank account instance. To do that, we can use a class constructor. So in this lesson and the upcoming ones, we will learn about constructors and various ways that we can use them to initialize member variables. Okay, so let's add a constructor to this class by typing bank account using exactly the same name as the class name. And then we can add some parentheses and we can add a double balance argument. And our goal is to initialize this member variable with the value of this argument. To do this, we can add some curly braces to define the constructor body. And now we have a problem because we can't just type balance equals balance, because this variable refers to the constructor argument and not the member variable that we have declared here with the same name. And in this kind of scenario, we can use a special keyword called this that is used to disambiguate between the names of the variables. So by typing this.balance, we are telling Dart that this member variable should be initialized with the value of this argument. And as a proof that this works, down here in the main method, we can update this constructor call to pass an initial value of 100, and then we can delete all this code and replace it with a print statement that prints the balance. And if we run the program now, we can see that the output is 100. Okay, so we have figured out how to initialize member variables by providing arguments to our class constructors, and we have seen that we can use the this.syntax to disambiguate between member variables and constructor arguments. However, there are better and simpler ways of initializing member variables, so let's continue on the next lesson where I'll show you how. In this lesson, I'm going to show you some better ways of initializing member variables with a class constructor. And one way to do this is to use an initializer list. So let me show you how this works. Over here, we can remove this constructor body entirely, and instead we can add a colon symbol, and after that we can type balance equals balance and a semicolon at the end. And when we do this, Dart is smart enough to know that the variable on the left hand side of the assignment is the balance member variable, and the variable on the right hand side of the assignment is the balance argument. So in this case, it is redundant to use the this.syntax because we are inside an initializer list. And since we can initialize the balance like this, we no longer need to assign it to 0 when we declare this variable. Now, suppose that we wanted to add one more instance variable representing the name of the account holder. To do this, here we could add a string account holder like this. And because we added this, we also need to provide a constructor argument for this variable. And to make this constructor easier to use, here I suggest that we use named arguments. So here we can add some curly braces to make the initial balance a named argument, and to make Dart happy, we can give it a default value of 0. And then we can add the remaining argument. So here we can type string account holder, and because this variable is non-nullable, then here we can add a required annotation to make Dart happy. Finally, we need to do one more thing, and that is to assign this argument to this instance variable. And to do that, we can update our initializer list and add account holder equals account holder and then a comma. And if we want to make this code a bit more readable, we can add a comma at the end of this argument and press the format button up here. Okay, so let me unpack this for you. What we have just done is to update the bank account class to hold two member variables called account holder and balance. And we have added two constructor arguments to initialize these variables. And since they are both non-nullable, we have made the first one required and added a default value to the second one. And in order to assign these arguments to these variables, we have used a so-called initializer list. The initializer list starts with a column symbol and is followed by a sequence of assignments which are separated by commas. And once again, in this example, both the arguments and the instance variables have the same name, but Dart is smart enough to know which is which in the initializer list. And now that we have this, we can update our constructor call in the main method to use these name arguments and type account holder equals to Andrea and balance equals to 100. So this is how we call a class constructor that uses named arguments. Okay, so let's get back to our class declaration, and as we can see, the initializer list is quite verbose because we are repeating the names of these variables too many times. So what I'm going to show you next is a shorthand syntax that we can use to achieve the same result with less code. First of all, we're going to remove this initializer list entirely like this, and then we're going to remove this argument type, and instead we can type this dot, and we're going to do the same thing here. And when we do this, we are saying, hey Dart, use these constructor arguments to initialize these instance variables. And by doing this, we don't need to specify an initializer list by hand. In summary, we have now seen how to declare a class constructor and how to pass arguments to it. And we have seen that we can initialize arguments either with an initializer list or with this shorthand syntax. In practice, you'll be using this shorter syntax most of the time, but as we will see, we will use initializer lists later on when we talk about class inheritance. By the way, I should also mention that by convention, in Dart, constructors are always declared before any member variables and methods, so we'll use this convention going forward. Finally, note how the syntax for creating a class constructor is quite similar to a function declaration, and the main difference is that we don't need to declare a return type, because by definition constructors are used to create and return instances of the class that they belong to. Okay, so let's continue on the next lesson. In this lesson, I'd like to talk about mutable and immutable state when we work with classes. You see, when we have created the bank account class, we have added these two variables that represent the name of the account holder and the current balance. And as we have seen, the balance is something that can change. And in fact, we have added two methods to deposit and withdraw so that we can do useful things with our bank account. However, we could argue that the account holder is something that shouldn't change, because when we create a bank account, that is tied to an individual and we shouldn't be able to change the account holder. But with the current setup, it is perfectly possible to type bank account.account holder equals Alice, and this will change this property. And if we want this to be not possible, then we have to make this an immutable variable, and we can do this by declaring it as final. And once we do this, we get an error on this line that says that account holder can't be used as a setter because it's final. So we can remove this line. On the other hand, it wouldn't make sense to declare the balance as final because we have designed this class explicitly so that the deposit and withdraw methods can modify the balance. So when you create classes that model some things that exist in the real world, you should always ask yourself if each one of the properties should be mutable or immutable. And you can declare immutable properties with final. And perhaps the more important takeaway is that class design is type design, and you should always strive to make your types easy to use correctly and hard to use incorrectly. In any case, as we make progress, we will keep these considerations in mind, and I'll point out when things should be mutable or immutable. Okay, so let's continue with an exercise.